Good morning. Oh, how's everybody doing? Mm. We had an agreement for 7:45. What happened? Was it the cocktail dinner? Guys, we said 3 drinks. What happened? Did you at least enjoy the cocktail for those who were able to? Okay, I'm glad. I'm glad. Um, Day two. We appreciate the commitment. We're happy that you're all here seated, and we're looking forward to a power-packed day. And I can promise you today's presentations, you want to hang in there. So we're going to quickly do our evaluation from yesterday. We just want to hear some feedback on how you found the sessions yesterday. And Salim is going to take you through that. And then he's going to put on his game master hat because we definitely have the trivia. We have to give away those prizes. So I hope you're looking forward to that. And so I'll hand over to Salim, and Salim, your audience.
Awesome. Thanks, Adina. Good morning, everyone. Okay, so I hope we're all familiar with Woo Clap from yesterday. We should all know the drill. Phone, to scan the QR code, or you go to the website and enter the code there. I'm just gonna 2 minutes for everyone to get onto it. Is there anyone struggling? Someone need help? We good? Can we get started? Okay. Okay, let's go. Let's go. First question. Let's maybe find out some information from you guys. What country are you from? Just the code is still here at the top. Do you still need this code? Okay, there's a very nice mix of all the different countries. I'm just gonna go on to the next one quickly. Which of these would be the hardest to live without? So you can live without chocolate, music, your favorite drink. That's a depends what drink it is, your phone or TV. Okay, a lot of people are addicted to their phones. We could. So how about this? Everyone who's saying you can't live, everyone who's saying you can't live with your phone, no? How about we try something today? How about you give us your full attention for the day? Keep your phone in your room, focus on the session. Same goes with laptops, no? We don't want to see them today. We want you to focus. Okay, next one. If you could pick a superpower, what would you choose? Some would fly, some would teleport. Eradicate polio. That. Who chose that? Good one. How is there people saying, oh, end hunger, eradicate VPDs? Who put money as a superpower? Guys, okay, now let's get serious. Just remember, think back to yesterday's sessions. And we're going to ask you how useful was the information presented in this session, the emerging trends in vaccinology and implications for Africa. Mostly what I learned is important and I'll apply it. Some of it's useful to my work, some not. And what you learn is interesting, but you don't really think you can apply it in your work. Do we all still remember the talk? Yes? Good, good. Okay. I'm gonna move on to the next one. So the next one is asking about the session after that. So Mpox, lessons from recent outbreaks and strategies for future preparedness. Are we ready to go to the next one? I'm moving. So now think back to the session that Beverly gave on cholera in Africa, the outbreaks, public health response, and the roles of vaccines. Did you think it was important and you're going to apply it? Some of it was useful, it was interesting, but some not. Or it was interesting, yeah, but you're not really going to do anything with it. Okay. Then session after that, immunization during crises, navigate. Okay, fair enough, right? Remember, we had issues with this one. Don't judge it based off the issues. Think of what it could have been, the information that did come through. Okay, I'm going to move on to the next one. Resilience and innovation, building stronger immunization program in Africa's dynamic landscape. How did we find that session? Next question. List anything new that's applicable from those sessions yesterday. Anything. What did you learn? What did you learn that is new and that you might use going forward with your work? Resilience and innovation. Yeah. Okay. If you have anything to add it now. So after the, do I still have time to do the quiz? Okay. So now we remember the quiz from yesterday, and we said we have a lot of prizes to be given out. Get your brains ready and focused. We have another prize to give out. I'm gonna close this now. No, is anyone still busy? I'm gonna close it. You're going to have to scan a new code now. If you don't mind, just connect to a new one. It's this code here to participate in the quiz. Remember what we said? The fastest, whilst getting the right answer, is the winner. Don't take your time. You're going to lose, but don't be wrong also. The prize, it's a surprise prize. It's good though. It is good, right? It's worth it. Uh, yes. Are we waiting on anyone? We good to go? Okay. First question gonna come up. We're moving on to it. Now, 20 seconds, true or false? Administration of multiple vaccines can overwhelm a baby's immune system. And time's up. False. Okay. 26 people. Good. Are we ready for the next question? Go. True or false? Wild polio virus types 2 and 3 have been eradicated. You have 12 seconds left. 5, 4, 3, 2. Okay, time's up. Correct answer? True. That was a tough one. Hey? Were people guessing or? Yeah, people are guessing. Okay. Okay, it's fine. Next question. Let's go. Why is using adjuvant in a vaccine preparation advantageous? There's 4 options. One is correct, no? Which one? I don't know. Okay, time's up. Is there anyone who's super confident in their answer? Are you super confident? What's the answer? 3. Nice. Okay. Okay, people knew. Cool. Okay, next question. There's 2 more left. Passive immunity is provided through. You have 15 seconds left. 5. Okay. I hope people know this. I don't. Correct answer? 2. Okay, 6 people knew that. Could 1 also be true? Okay, well, 1 could be correct, but at the moment, Beverly, 2 is correct. So if you chose 2, you are correct. We can debate about 1 later. Okay. Final question after this. Are we ready? Adverse events following immunization can be categorized as? Five seconds left. People ready? Okay. This is another question that is anyone super confident about? All of the above. Yeah. Okay. So now we want to see who won. Who was the fastest and who got the most correct? Are you confident? Are you confident that you won? Oh, okay. So let's see. Cool. Well done. Okay. So yeah, okay, prize. We will have another quiz later today. So make sure your brain stays awake and sharp. I'm going to hand over to the chair, Imen, and yeah, she'll introduce us.
Good morning, everyone. So my name is Iman or Iman, and I will be chairing this session. We're starting 20 minutes late, so I don't know. Maybe we will go late in lunch. I don't know. But let me start with our first speaker. Is Prof. Elisa Nemes. I hope that I'm pronouncing your surname right. So Prof. Elisa, she's a principal investigator at the South African Tuberculosis Vaccine Initiative, or SADV, which is like the leading research group about TB vaccines. And she is a member of Institute of Infectious Disease and Molecular Medicine, IDM, Division of Immunology, Department of Pathology, Faculty of Health Sciences, University of Cape Town. And she will be giving us a talk today about basic principles of immunology and application in vaccinology. It's over to you, Prof. Thank you.
Good morning, everyone. It's a pleasure to be here again, as every year. I'm just waiting to see my slides. So it looks like you've done some immunology yesterday. This is a topic that some people find a little bit warning or threatening, but hopefully it's not gonna go that way today. What I'm gonna do is to try and go over some basic principles of immunology and see how we can apply them in vaccinology. So to start, if we can start, it's not going. Yes. Okay, so we start reflecting about how we do acquire infectious diseases. And as you know, there are different ways. We can acquire them through direct contact, exchange of body fluids, contamination of food or water, some we breathe, and some are transmitted by vectors. So immunology is a field that studies how our body defends us from pathogens. And so if you think about it, the first line of defense is your physical barriers. So your skin, your mucosal surfaces, etc. But the immune system is a complex system composed of different organs that are spread throughout the body, cells and molecules. So when we think about the immune system, the first big division is between innate and adaptive immunity. There are different cells that contribute to these different arms of the immune system. On the left, you see some examples like phagocytes, complement dendritic cells. And on the right, you see B and T cells that constitute adaptive immunity. For now, the main differences that we need to remember are that the innate immune response is quick. You see at the bottom that it normally only takes a few hours for your innate cells to recognize a pathogen. But they do so in a non-specific way. This means that, for example, these cells can make the difference between your own cells and a bacteria or a virus, but they will not respond in a different way depending on which pathogen they see. The other key feature of innate immunity, with some exceptions, but we don't go into exceptions today, is that it does not remember. So your innate immune response will more or less respond in the same way every time it sees the same pathogen. On the other hand, your adaptive immune response, it's slow, so it takes several days to develop, up to a couple of weeks, but it's specific. So it means that there are different T and B cells that recognize different pathogens, and within a given microbe, they recognize different structures. And the key feature of adaptive immune response is that these cells remember. And this means that they react in a different way depending of whether it's the first time that they see a certain microbe or if it's the second, the third, and so forth. And this is the key principle in vaccination. I'm going to give you one definition, which you may have heard yesterday already, but it's just, I'm going to say this word so many times that it's better to be clear. So what are antigens? So we call antigens any structural substance that is recognized by the adaptive immune response. So it's essentially what B and T cells can see. And we can distinguish between self-antigens. So these are from within the body. And normally they should not induce an immune response, because if you do, then you have autoimmunity, which is a pathological event. What we're interested in are non-self antigens, so that they are foreign to the host, like, you know, microbes. And these should induce an immune response. And these are generally proteins and large polysaccharides that, you know, you find on the surface or inside bacteria, viruses, and other parasites. So again, to go a little bit deeper in the different types of immune responses, we mentioned we have innate immunity, and macrophages and dendritic cells belong to it. Their job is to recognize molecular patterns on microbes that are different from what you will find on your own cells. What they do once they do that, they communicate danger signals to other cells. This is inflammation. So basically your innate immune response is mostly driving inflammation. And then the other key thing that they do is that they take up these microbes and they present antigens to the adaptive immune cells. And this is very important to initiate an immune response. We mentioned there are two types of adaptive immunity. T cells, again, they recognize specific antigens, but they only see proteins. This is very important because some bacteria are covered by polysaccharides or sugars, and the T cells will not see that. And also they see protein antigens only when they're on antigen-presenting cells. They don't see antigens floating around. They have two main jobs. CD8 cells kill infected cells to remove them. And CD4 cells or helper T cells, they orchestrate a broader immune response. The other part of adaptive immunity is constituted by B cells or humoral immunity. B cells also recognize specific antigens, but they can recognize both proteins and polysaccharides. So this is a key difference between antigen recognition of T and B cells. And what B cells do, they make antibodies. That's their main job. So going a little bit deeper now into how adaptive immunity works. So B and T cells recognize different types of antigens. B cells can recognize intact antigens directly. So if there is a toxin floating about, a B cell can see that. While, as I mentioned, T cells only see the antigen when it's presented to them by another cells. Be it because phagocytes have eaten up the microbes and present the antigen, or if a cell is infected directly, for example, with a virus, it will also present antigens on the surface for T cells to recognize it. So once they recognize their antigen, these cells proliferate and differentiate into more specialized cells. So on the left, you see B cells become plasma cells and memory B cells. And as I mentioned earlier, these cells secrete antibodies that defend against extracellular pathogens mostly. While T cells also proliferate, differentiate into memory and effector cells, and their job is to mostly defend against intracellular pathogens and cancers and transplant tissues. This is a key difference because when we design a vaccine, we can kind of direct which kind of immune response we want at the end of the day. So if you want to induce an immune response against an extracellular parasite or the extracellular phase of an infection, then you rather want antibodies. If you want to induce immunity against a predominantly intracellular pathogen, then you want to induce T cells. And this is a big key distinction that people think about when they do design new vaccines. So in general, though, these immune responses work together. So you never have just the one or the other. But when you think about different phases of an infection, you can think that in general, antibodies prevent infection, so they can neutralize, for example, viruses before they even get to infect cells, and dissemination, while T cell responses are more important to prevent severe disease. From the questions I just saw, probably you went over this already yesterday, but essentially we can make two big distinctions between active and passive immunity. Active immunity is the one that your body develops itself, and it can happen following natural infection, or it could be artificially induced by vaccination. While passive immunity is generally antibody mediated, so it's what we can give antibody to someone. This always happens during pregnancy and breastfeeding, or there are now some therapeutics where you can literally infuse antibodies to a person. So what do vaccines do? They prevent disease by teaching our immune system how to fight off infections before they happen. That's really what vaccines are meant to do. So what's in them? So if you start on the right, the most important components of a vaccine are the so-called active ingredient. So these are very small amounts of a portion of a pathogen that you want to induce your immune response against. So that's what gives it specificity. Often vaccines contain adjuvants, which are substances that we add to induce a stronger immune response. And then the rest is water. There are generally some preservatives and stabilizers, and there could be some residual traces of other substances that were used during the manufacturing. These last two could cause allergy in some people. So some people who maybe cannot be vaccinated, it's mostly because they react to these preservative and traces elements rather than the more specific part of a vaccine. What's important in general is that the basic components of a vaccine will shape the type of immune response that you're going to get. So from left to right, when we choose which antigen we put in the vaccine. So these are the bits and pieces of your microbes that you choose to induce an immune response against. These, of course, will determine the specificity of a vaccine. If you don't put an antigen in there, that vaccine will not induce an immune response against an antigen that's not there, right? And the breadth also, you know, some vaccines may contain multiple antigens from the same pathogen, and some may contain just the one. So this is all determined when we start designing our vaccines. Then formulation is very important, and here I'm referring to the different types of vaccines. We'll go over them in the next slide. But the dose is very important. This is also something that we can control, and depending on which type of vaccine, the diluent and the dose, it will determine the magnitude of the immune response, or how much of it we get, and the quality, which kind of immune response we're gonna get. And then delivery is also very, very important. So we have a vaccine in a vial, but depending how we give it to people, this will also have an impact. So for example, your immunization schedule, the route of administration. And then there are special considerations for different age groups or people, for example, with other comorbidities. And all of these decisions that, you know, some of you make in your work will determine how effective that vaccine is going to be and how long the immune response is gonna stick around. This is a busy slide. You'll have all the slides, so I'm not assuming you to read it now, but essentially this shows in chronological order from top to bottom different types of vaccines and how they evolved over time. The key take home here is that this development was possible because of our increased understanding of host and pathogen interactions. So the more we understand how things work, the more we can design a product in a very rational way. But also the development of biotechnology, so the things that we can do in the lab. So for example, if you think about the first vaccines in the 1800s, microbiologists were isolating a bug, they were inactivating it and injected into people, and then they started completely killing the pathogen. But then over time, they realized that, you know, maybe it's just a toxin that's harmful, and so you can isolate the toxin and just give that. And then as technology evolved, now we can synthesize in the lab proteins and adjuvants that we can combine together. We can do viral-like particles. These look like a virus, but they're empty. So for the immune system, it will look like a virus, but it cannot cause disease. Protein and polysaccharide conjugates, I'll talk about those a little bit later. And then the latest ones are really based on genetic engineering. So you can take a virus, you can take out this genome and put in the genes that you want to induce expression of the antigens that you're interested in. And the very last kids on the block, as we all know, is the RNA vaccines that really saved us during COVID. And that is only based on a string of genetic material. So let's try and put all of these bits and pieces together. So what happens when, for example, we inject a vaccine in the skin or in a muscle? There are dendritic cells which roam about in our surfaces. So dendritic cells will pick up the antigen that is in the vaccine, and they will recognize the adjuvant or other parts of the vaccine that gives this danger signal. So at that point is when you have inflammation, but that's a good thing. That's what they're meant to do, right? They need to throw that danger signal around. But you also have reactogenicity. So if you think about, you know, your swelling and induration and a bit of fever and pain, etc., those are your innate immune cells that they're doing what they're about to do. It might not be pleasant, but it's a good sign. Unless it's too much, of course. Then they become activated and they move from, for example, the skin or the muscle, they go into the closed lymph node. In the lymph node, they present those antigens that they pick up from the vaccine to T cells. As we said earlier, T cells then they proliferate because imagine, your T cells are specific. Every T cell only recognizes one bit of one pathogen. So they're not that we don't have many of them, because otherwise we will just be full of T cells, right? So when one of these very rare naive T cells sees the antigen, the first thing that they do is that they need to make more of themselves, because two cells are not going to fight off the infection. So they proliferate, and this is why the adaptive immune response takes longer. It takes time for these cells to make more of themselves, and then they differentiate. And then the vaccine antigen can also be presented to B cells, or as I mentioned, B cells can see directly. And they also proliferate and they differentiate into memory B cells and plasmablasts. And then the long-lived plasma cells go into the bone marrow and sit there for many, many years. Now, what is key is that B cells can make good memory only if they receive help from T cells. This is really key. It's a key function of T cells, and understanding this bit was what allowed us to make conjugate vaccines. Conjugate vaccines, we put together a sugar, a polysaccharide that the T cells don't see, and a protein that the T cells can see. We trick our own immune system into thinking that they're seeing the same antigen, but they're not, but they're just next to each other. And so the T cells get activated in response to the protein, and they give help to the B cell that's in the polysaccharide. And that's how we make good memory B cells against polysaccharides with conjugate vaccines. So our immune response, like everything in the body, evolves over time. So when we're born, the immune system is rather immature. It means it doesn't work as well as when you get a bit older. And at the opposite side of the age range, when we get older and things start being tired, our immune system also gets tired. So our immune response is not optimal during the first few years of life and the last ones. There are also big changes that happen during pregnancy because the baby is a non-self antigen. So your immune system needs to regulate itself so that you can allow essentially a foreign body to grow inside of you. So in these moments in life, there are special considerations. And also, these are the moments when we are more vulnerable, right, to infectious diseases and when we need the vaccine the most. But then knowing how the immune response changes over time helps us. For example, when you decide on a vaccine dose, an immunization schedule, you may need more vaccine, for example, in an elderly person. So again, understanding how our immunity changes over time helps us making different decisions when it comes to which type of vaccines we give and when. Another key feature is that, as I mentioned, your immune system is everywhere in your body, but we really want to direct it where it's needed. And again, that link where when we understand how transmission of a certain pathogen happens, for example, if it's by air, you rather want your immune responses in your airways and so forth. And so we can, to some extent, direct our immune response depending on how we administer the vaccine. For example, if we inject it in the skin or in the muscle, like most vaccines are, this route of vaccination is very good at inducing systemic immune response. It means everywhere in the body. But for example, if you really want mucosal immune responses, maybe it's better to give a vaccine orally, for example, to get immunity in the gut. Think about oral polio, or by aerosol or intranasally. I think until COVID, there might be one influenza vaccine that can be given intranasally, but those routes are not common, but they're very actively studied now because of so many diseases that can be transmitted by air. There are obviously more safety concerns there, because you don't want to induce too much of an immune response in your airways, right? You want to breathe. So it's a bit of a fine balance between having a strong immune response, but not interfere with your physiological body conditions. Okay, so this is the key take home. So everybody wake up. It's immunological memory. So our adaptive immune response, as I said, does not react in the same way all the time. We have a primary immune response that happens the very first time that we see a certain pathogen or a vaccine. So that's what we want the vaccine to do. We want it to induce this primary immune response. Why? Because the secondary immune response is better than the first one. What happens is that the second time that we see, or multiple times that we see the same antigen, our adaptive immune response is faster, way faster. And it's stronger, we have more of it, because we already made those precursor cells proliferate the first time around. And it's in generally better. So if you think about antibodies, they mature, they class switch, they increase how well they can bind to an antigen. So essentially, this is what we're trying to do. We want to induce that primary immune response without the risks associated to having a natural infection, so that the second time that we see the same microbe, we can react better. So memory is wonderful. These cells stick around for a very long time, but for how long? Well, the answer is like it depends. Some immune responses, once you induce them, they are there forever. And some others wane over time. Why is that? It depends. Again, it's many factors. It can be different for a different vaccine or a different disease. And this depends on the vaccine type. So for example, like natural infection, live attenuated vaccines generally induce a much more durable immune response. You know, think about yellow fever, measles, etc. And then it depends which kind of immune response you want. Memory B cells can stick around much longer than memory T cells, for example. And then it depends a lot on natural exposure. Is this a bug that we see all the time and it can, you know, remind our memory cells that is there, or is this a once-off exposure? And then it depends on the population, the environment, and unfortunately also many unknown factors. So what we went over now was how immune responses are primed, or in a way, how do we induce, what happens when we first induce a response? If that memory wanes over time, we may want to boost it. It means that we give the vaccine again, so that those memory cells that are sitting in the lymph nodes and in the bone marrow, they just get a bit of a wake up, they proliferate some more, and so they kind of maintain their level over time. Now we have options. We can do what's called homologous or heterologous prime boost. So I think until COVID vaccines, really, we always had homologous prime boost. It means the same product, you just inject it again. And now we've seen examples where we can actually use different vaccines for prime and for boost. And this is quite cool if you think about it, because different vaccines can induce different types of immune responses. So maybe you want that, you know, you want to give the same antigen, but maybe you have a product that's very good at inducing antibodies and another one that's very good at inducing T cells. And maybe you want to combine them. The other concept that we see, you know, when we test vaccines in diseases that are not cleared, but again, really became very prominent with COVID, is what we call hybrid immunity. I mentioned at the beginning that active immunity can be either induced by infection, natural infection, or vaccination. So now we call hybrid immunity when we have both. So we either have first infection and we vaccinate on top of it, or we first have vaccination and then we have breakthrough infection. The key point here is that it looks like hybrid immunity is actually much better than either natural immunity or just vaccine-induced immunity. It can change the kinetics of which kind of immune responses we get, and it can really increase our antibody responses and have much better memory B and T cells. So I talked about immune responses in general, and there are different players that all are important, but it does not mean that all the immune responses that I mentioned are essential for protection. So when we talk about immune correlates of protection, we talk about a measurable immune response that predicts vaccine efficacy. It's something that if you see that, you know your vaccine is going to work. And this is super important because for the vaccines for which we know what the correlates of protection are, we also have a threshold. We have a number. We know we need to be above that number. And this is super helpful because you can just do a blood test and tell if somebody, for example, has lifelong protection, if they maintain those levels of antibodies for a long time. If you see it waning over time, you know you need a boost. And unfortunately, some people they just don't develop a protective immune response for a variety of reasons. So when we talk about correlates of protection, it's different from correlates of risk. So correlates of risk are immune responses that we look for that are associated for increased risk of a disease. They help us understanding better what we should do or not do with a vaccine. But these are regardless of vaccine efficacy. When you talk about protection, you're really talking about a certain immune response that's induced by vaccination, and it's mostly defined in clinical trials where you have a placebo arm, and it implies vaccine efficacy. Now, it's important when we talk about correlates of protection to define protection against what. And again, an example from COVID, you know, at the beginning, it wasn't too clear what these vaccines were meant to do. And so some people might have been disappointed because, you know, certain vaccines did not really protect against infection, but they were protecting against hospitalization and death. But it could be misinterpreted that if it doesn't protect against infection, then it's not a useful vaccine. But that's not true. So it's very important also when we design clinical trials to define exactly what our endpoint is. You know, what do we want protection against? Do we want protection against symptomatic infection, disease, hospitalization, death? There are all different considerations there. So, but why do we spend so much energy trying to define correlates of protection? That's one of the main things that I do, is because they're very useful. So if you do not have a correlate of protection, like in the case of tuberculosis where I work, there is no way you have a new vaccine, you need to test it on thousands and thousands of people to see if it works. And then maybe you collect the samples and you retrospectively try and understand if the vaccine works, what was different between those who were protected and those who were not. For some diseases, we have controlled human challenge models, like in malaria. And this is an incredible tool because you can vaccinate and safely infect people in a very small number. But because you can control both the vaccination and the exposure, you can understand a lot of what this protective immune responses are, and then you can apply that to a big population. For the vaccines where we know what the correlate of protection is, it's a wonderful early measurement that will tell you if the vaccine is going to work or not. And this is important when you want to, for example, bridge to certain populations without repeating an entire efficacy trial. If you know what the correlate of protection is, you can give the vaccine to specific population, just measure the correlate and predict vaccine efficacy. So I really like this slide. This shows on the y-axis which type of immune responses are protective. So antibodies on the top, T cells at the bottom. On the x-axis, you have the stability of the antigen. It means how often that bug mutates. What you can see is that virtually all successful vaccines that we have, they are in the top right. And these are mostly acute infections where natural immunity is protective. So all we need to do is to induce the same type of immune response with the vaccine, we're done. There are other diseases that you see there at the bottom. Those are the ones for which we don't have vaccines that works wonderfully. And these are all chronic persisting infection where natural immunity is only partly protective. So these are the difficult ones. All what I've talked about today is how our immune system directly protects us. But vaccination can also protect others through indirect protection. And this is the concept of herd immunity. So on the left here, what you can see is that if you have contagious people who are surrounded by susceptible people, an infection can spread very, very quickly. That was the beginning of COVID. But if you immunize and people, then the contagious people cannot spread to the immunized. Well, they will, but then the infection dies there if the vaccine protects against infection. And essentially, the immunized people can shield others who cannot be vaccinated for various reasons, just because they decrease transmission on a population level so much that then the pathogen cannot go around freely. So this slide tries to bring it all together. It was quick, but we've talked about many different factors that ultimately affect if a vaccine is going to be efficacious or not. We talked about the type of vaccine that we can design. We talked about how there are different ways of giving it, which dose with adjuvant, the immunization schedule, but there are other factors that are not quite in our control, like age, other infections, environmental factors, and genetics. And all of these will influence how our immune response develops, for how long it sticks around, and ultimately vaccine efficacy. There are still many barriers that remain for certain diseases. TB is certainly one of them. Because some vaccines are just poorly immunogenic. I'm talking to the bottom right. We don't quite know why. For certain diseases, we don't have correlates of protection. So sometimes you kind of shoot in the dark if you don't know which kind of immune response you should induce with your product. Some diseases have a lack of animal models, which are quite helpful in the preclinical phases of development. But as you can see here, this is just one small part of a bigger problem. And this is why you're sitting here for a week, because over this week, you will learn about all these other boxes and how implementation is essential, issues with host variability, the pathogen variability, safety concerns, and then the environment and geographical factors. So with that, I conclude, and I'm happy to take any questions here or just drop me an email. Thank you.
Thank you, Prof, for the very insightful. You hear me? Okay. So if there are any questions before going to questions online, okay.
Thank you very much. That was a great presentation. You mentioned the main purpose of why we have vaccines. They also induce primary response. So I wanted to know if there are cases of vaccines that does not induce primary immune response.
Not the ones that work. What do you mean? That they're not able to do that?
They go straight to the secondary response.
No, it's not possible. So, well, it's possible only in the case of hybrid immunity, right? So the primary immune response is just the first one. So there must be a first one. But there could be cases where the primary immune response is induced by natural infection, and then you vaccinate later. So it's almost like your vaccine works like a boost. So your memory cells would have been formed from the primary infection, but then your vaccine can amplify them. And the other thing is that because we have control, over which kind of immune response we induce with vaccination, there are also cases of unnatural immunity. So you could maybe try and induce an immune response that normally will not develop in that way.
Just I have it's very nice presentation. Firstly,
Thank
you so much for that. My question is regarding malaria vaccine. I saw that it's works under T cell, but really I want to know how malaria vaccine works.
That's a complicated one because it's complicated because the malaria life cycle is so complicated. So actually, it's kind of in the middle. So I think some of the most promising vaccines, they do induce antibodies, but it really depends in which stage of the life cycle of the parasite you're looking at. So for example, when it's in the blood, then antibodies can indeed neutralize it or prevent entry into the red blood cells. But during the liver stage, for example, CD8 cytotoxic T cell responses have been associated with protection for the liver stage. So that malaria is a great and tricky example because, for example, you want to induce maybe antibodies against certain antigens that are visible or accessible during the blood stage, and you want to induce T cells against antigens that are more visible in the liver stage. And in that case, for example, if you design an antibody vaccine that induces antibodies for something that's only present in the liver stage, then it doesn't work. So it's both. And it really depends on the product, and it depends on the antigen that's put in the vaccine.
Okay. Thank you. My question is about adjuvants. Usually, the adverse effects of vaccines are associated with the use of adjuvants in their composition. So I have two questions. What are the different types of adjuvants used in vaccination?
There are many tables of them, but
And
yeah.
are there any recommendation or regulation regarding the use of adjuvants?
Okay, so the first question is that there are many products, and one of the older one is called alum. It's really designed to induce antibodies, but really it's a whole branch of science in itself, designing adjuvants, and so there are many. I can list them, but and as I mentioned earlier, because the adjuvants are so important to those initial steps of the immune response and inducing this danger signal, that's when maybe the inflammation is a bit too much, then you can have adverse events that you need to consider. Is it too much reactogenicity, is too much adverse events compared to what you could get from the real infection? These are normally decisions that are made based on data from clinical trials. There are very accurate measurements of that initial reactogenicity and also what more rare adverse events are. And it's always a balance between risks and benefits. No, it depends, right? So it depends on the pattern, on the disease. It depends on the epidemiology. If it's a disease that's very prevalent in a certain country and causes a lot of death, you as that country might accept a vaccine that is still safe, but gives a bit more of a reaction. So it's more unpleasant to get it when you balance out how many lives you can save. So this is why it's important to, have representation here from many different countries, because there are decisions that you guys need to make that really depends on your population, your epidemiology, if a disease is prevalent or not, what the morbidity and mortality is. There isn't one answer that's generic for this question.
Thank you so much. We are running out of time, so you still have Prof here. You can like ask her during the tea break, and I want to give opportunity to the online attendees. So I will take two questions, and then also Prof will able to answer the rest of the questions on the tablet as well.
Okay, so I'll be the voice of the online participants today. So we have the first question from Tambe Elvis. And his question is, he usually hears professionals referring to the vaccine as an antigen. Is it proper? He certainly doesn't think it is. And the second question is from Laurie Bridget, and she's asking whether it's possible to develop resistance to a vaccine.
Okay, so the first question is, the antigen is only one part of the vaccine. So they're not the same thing, but the vaccine needs to contain the antigen. So it's a part of it. And the second is that you don't really develop resistance to a vaccine. It's just that if you vaccinate, for example, for a certain variant of a virus and the virus changes, then of course the immunity induced by that vaccine will not recognize the new antigens if the virus has changed. Because as I said, you can only induce what you put in your vaccine and not what you don't put in the vaccine. And then there are some other pathogens that, have developed to have immune evasion mechanisms. So they might evade even the immune responses that are induced by vaccination. But that is why it's important to, basic scientists like me to understand all of these things so that we can take that into account when we decide which antigens we put in the vaccine and how we formulate it to make sure that doesn't happen or it happens as little as possible.
Prof, if you could just come answer some of the questions. Thank you.
So our next speaker, I'm particularly looking forward to his presentation. He is Prof. Michael Gold, and he is an immunologist, allergist with established international and national profile in the field of vaccine safety and allergic disorders. Prof. Mike has over 20 years of trial experience as both principal investigator and investigator-led randomized control trials and co-investigator. His specific interests have been in the field of pediatric food allergy and the surveillance of adverse events following immunization. So he is going to give us a talk today about introduction to adverse events following immunization.
Morning, and thanks to the organisers for inviting me yet again. We won't have a quiz as to who's the oldest in the room, but I think I'm behind Greg, so I don't think I'm the oldest. I was reflecting on Adina's presentation about COVID, and one of the things I've learned in life is never to waste a crisis. A crisis should never be wasted, because that's often when there's the opportunity for innovation and for change. So I thought I'd start off by asking the question, what have we learned about vaccine safety during the COVID pandemic? So this seems to be a very interactive group with lots of engagement. So let's just take a moment just to get a bit of feedback from the group and to think in your own countries. And in particular for vaccine safety, what did the COVID pandemic kind of teach us? Because moving forward, some of those innovations or some of those findings that happened may be useful to us moving forward. So does anyone want to start? I've got some points. Annalie? Yep, thanks. I just want to get...
Okay, thank you. So I'm speaking from the South African perspective, and I would say in capital letters, a lot for everybody. And I think what we all have learned is that we need to be vigilant and, be active. We also learned that surveillance is so important, and I always say it wherever I go. There's a lot of funding going into, other things around vaccines. But when it comes to surveillance, nobody thinks it's important until the poo-poo hits the fan and there's a problem with the safety of the vaccines. So that's very important. We've learned that. And for vaccines, you cannot compare it with other drugs, in terms of the investigations. And then lastly, it actually resulted in vaccine safety becoming a household term because everybody was just talking about the safety of the vaccine and as the most important factor having an impact on vaccine hesitancy. Thanks.
Yes. So to me, just to pick up on a couple of those points, we know that we're going to talk about passive surveillance of adverse events. I'm going to explain what an adverse event is. But in general, for many countries, adverse event surveillance is not very robust. But certainly for all countries, we were able to demonstrate that we could enhance adverse event surveillance during COVID. That's the first point. And then secondly, obviously we'd been talking about vaccine safety for decades, but really with COVID, the focus was really on that. Is there any other points? Does anyone else want to?
Okay. What COVID taught me about vaccine safety is that even the simplest things that you normally take for granted can cost us so much that it can even cost lives. I'll give an example about something that happened in my country, Botswana. We were receiving a number of batches of the COVID vaccine. And then on one of the batches, one of the consignments, I think it stayed longer at the airport, longer than it should have. And I think they broke the cold chain somehow because some of the people that were sent to transport the consignment to the storage, I think they were not very well trained. They broke the cold chain there and the whole consignment had to be discarded. And that was the time when people really needed the vaccine. So something as small as maybe opening the consignment when you should not have, or longer than you should have, can cost people lives, can cost so much money. It meant that we now had to order another consignment of vaccines.
Yep.
So things as simple as that, they can be very crucial to vaccine safety.
Yeah. And I suppose to an extent, the robustness of the program before COVID, really influenced during COVID.
I think what the main thing I learned is if there's will, you can do a vaccine quite quickly. But I think for me, I think what it showed is how we actually failed to have language to explain risk to people and to individualize that risk to the person sitting in front of us. In a meaningful way. So for instance, if you are a smoking person on, birth control, what is your risk of having an adverse event? And then obviously not to be dismissive of people that are complaining, because I think that's the worst thing you can do.
Yep, no, very good points. And I think we'll take one more.
Thank you very much. One of the things that we learned in Namibia was the need to explain to the public exactly what the vaccines do, because the normal way that the body reacts to the vaccine was now perceived as actually being adverse events. And this is also borrowing from the talk that Prof just recently gave, defining what the vaccine will do. Because now people ended up like, you just get sick and you still get sick even then you get the vaccine. So that's one thing I learned, that really taking this down to the community and explaining what happens, because traditionally vaccines are given to children. So yeah, they get a fever, it's okay. But now when it's adults who can voice what they are feeling and they like, we needed to explain that more. Thank you.
Yeah, no, fantastic points. And if I let you carry on speaking, I'll have no time to speak. But we'll have time for discussion at the end. But look, you've all made fantastic points, and I think the challenge is to basically try and carry that into obviously the routine immunization programs, and to continue. This is some of the thoughts that I had, and they were to an extent reflected by what people have just said. So the difficulty in established confidence in the safety of a novel vaccine. And clearly the challenges here were the accelerated development of this novel vaccine platforms, the emergency use licensure, the waiver of legal liability. All of these things undermine, obviously, community trust in vaccine. The fact that we were mandating, the fact that we were basically punishing people for not being vaccinated. There was false assurance of safety, and I think this comes back to the point about language. Poor risk and benefit advice, which was mentioned. How do we explain that to people? And within the context, I think, of loss of trust as well, because a lot of trust depends on transparency, conflicts of interests, social media and influence, and really for low and middle income countries. Remember that the vaccine was first obviously rolled out in high income countries, and a lot of the safety concerns and information really initially came from high-income countries, mRNA vaccines, and how did that impact on a low and middle-income setting? You can expect rare adverse reactions following licensure and use. And the point that I'm going to make repeatedly to you is that when a vaccine is licensed, the safety information is incomplete. And you've got to, that's a very fundamental point to understand, and I don't think was really explained completely. In terms of adverse event pharmacovigilance, we touched on this about passive surveillance and how surveillance is very important. Case definitions are clearly important as well. Causality assessment is critical, and I'll explain all of that to you. And I think differences in adverse event profiles between low and middle income countries and high income countries, I don't think have been completely understood and explained. So the clotting reactions that were mentioned earlier with the viral vector vaccines were hardly really documented in low and middle income countries as opposed to high income countries. And we don't really know if that's a surveillance issue or if it's a true issue in terms of environment and populations. I've just put this up now to really remind me that within this room, we have probably at least 29 different languages being spoken, and you all come from very different areas of expertise. So just by show of hands, how many of you are involved with vaccine safety or adverse event reporting, anything to do with adverse events within your country, within your program? Okay, so we've got, it's certainly a minority, okay? Certainly not many, it's certainly a minority. So the point I want to make is that we each coming at this from different aspects. So we each seeing vaccine safety from a different viewpoint. Much of what vaccine safety is about language, about the use of terms, and how we understand those terms. And really what I'm going to just touch on in the next 30 minutes or so are those basic concepts to do with vaccine safety. So I really want to just get you to understand three different concepts. The first one is why are concerns about vaccine safety important? The second is how do you know that a vaccine is safe? So if someone was to ask you, and this could be someone that you're vaccinating, or it could be a colleague, how do you know that that particular COVID vaccine, or how do you know that that pneumococcal vaccine is safe? What is your reply going to be? And this is not particular to that vaccine, but really what is the mechanisms that we use to really understand whether a vaccine is safe or not? And it comes back to the point made here about being able to explain safety to people. And then how do you know that a vaccine has caused a reaction? You'll see why that becomes very important as the talk progresses. So the first point that I want to make is that the concerns about vaccine safety affect coverage and not really concerns about vaccine efficacy. And you've seen this cartoon before in Greg's talk, and it's always a good place to start when you have a talk on vaccine safety, because this was a cartoon that appeared in 1800, and 1796 was the first medical publication of vaccination. And vaccination in one of the quizzes comes from cow, because cowpox was used to inoculate against smallpox. Now, although that was first described medically in 1796 by Jenner, it had been in the community for decades before. So local farmers, etc., knew that if you'd had cowpox, and that was usually the cowmaids who were milking the cows, that they would be protected against smallpox. The other interesting thing to think about is that all of that happened without people knowing about microbes or about immunology. So just think about the talk you've just had and how much detail we understand now about the immunology. But when vaccination was around, people knew none of that. This was just an empiric observation, something that they'd observed in the community. And in fact, it goes back even further, because for close to 2,000 years before that, people were inoculating with smallpox to prevent smallpox. And that was a very effective procedure, because it involves all of that immunology that you've just been taught. But it also had, obviously, you had a high side effect rate or reaction rate, because about 1 in 30 of those people died because they'd been given the live smallpox. So the vaccination was a lot safer than actually getting smallpox to protect against smallpox. And that's called variolation, and had been around for at least close to 2,000 years. So this is why it becomes important. So essentially, with vaccine safety concerns, there's loss of confidence in vaccines, vaccine hesitancy you're going to hear about later in the week. There's a decrease in vaccine coverage and breakthrough vaccine preventable diseases. And there are many examples of that. Going back into the 70s with pertussis vaccine. And I'll just focus on a few of these. I'm going to talk a little bit about measles, mumps, rubella, and polio, but clearly goes through even to COVID vaccination today. So where this fits in is really something that you'll be hearing about later in the week, I'm sure, and that's the behavioral and social drivers of vaccination. And this is one sort of conceptual model, and it really explains the different components that would take someone to be vaccinated. And what people think and feel is very important, and perceptions of risk is very important. And this relates to confidence and to trust. And this is where the vaccine safety comes in. Just to show you a little bit of evidence in relation to this, this is comparisons of vaccine hesitancy across 5 low and middle income countries. And you may not be able to see all the detail, but the first question is asking really how effective vaccines are. And if you don't think they're effective, you end up in the red bar, and you can see that virtually no one thinks that vaccines are not effective. But when we come to concerns about the actual side effects of vaccine, you can see that almost 50%, and that's in the red bar, of people surveyed in that study have concerns. So there are far greater concerns about safety than efficacy. And again, one study relating to COVID, and it's from South Africa, and again, a survey of people's attitudes towards vaccination and concerns in regards to COVID. And you can see that the top concern is relating to vaccine side effects. Now, these safety concerns mostly affect or have in the past affected newly introduced vaccines. And that, I suppose, makes intuitive sense. And, you know, prior to COVID, I think we'd had a lot of experience with HPV vaccination. And as you saw yesterday, I mean, there are many countries within Africa, but also within globally, that even today are introducing HPV vaccination for the first time. And you know, any introduction of a novel vaccine is going to be regarded or could be regarded as an experiment, which to an extent it is. And I'll explain to you why that is so later. And the bottom graph is the coverage of HPV vaccination. See if I can get the pointer to work. No. It covers the Nordic countries and in particular Denmark. And you can see that concerns about HPV vaccination and this condition called orthostatic tachycardia syndrome led to reduction in vaccine coverage for HPV. And COVID, I don't need to spend much on, but a lot of the COVID, and particularly as you've seen within Africa, the lower coverage rates would have related to reduction in confidence in that vaccine. But safety concerns can also be about established vaccines. So the classic example there obviously is the measles, mumps, and rubella vaccine. And the issue going back to the mid-90s about autism and the association between measles, mumps, and rubella vaccine and autism. And this is a graph from the UK showing the rise in the rates of measles. The dark orange are the coverage bars, and we know because measles is so infectious, you know, it has an R value between 12 and 16. And remember that with COVID, we were talking about an R value of 2 initially. You can see how much more infectious it is and how much higher vaccine coverage you need in order to prevent endemic circulation. And if you want to read that whole story, I can recommend this book to you that really covers the whole saga in relation to that. But even today, and some of the hesitancy, I mean, 2 decades later, we still are dealing with that issue. But the point I really want to make, obviously, is that the measles, mumps, rubella vaccine, an established vaccine, you know, why should there be concerns about it, considering it had been used for so long? And then obviously polio, again, going back to issues around the oral polio vaccine, issues around fertility, and I just want to show really how this can spread obviously globally and how that graph really can be replicated today in terms of spread of polio and vaccine-derived polio. It's important to really understand this vaccine safety cycle. And this it depends on the maturity of the immunization program in your country. And it can be obviously vaccine specific. So I'll just take you through this. This is quite an old graph. It comes from someone called Bob Chen, who used to be in the CDC, responsible for vaccine safety. And he sort of conceptualized this to say that when you have high disease rates and low vaccine coverage, you'll have quite an immature program. You won't have many adverse events reported because you're not using much vaccine. But there will come a point in your program when your vaccine's effective and you get a reduction, obviously, in disease being reported and higher rates of adverse events being reported because you're using more vaccines. Now, I'm going to explain to you the definition of an adverse event. And an adverse event is not the same as an adverse reaction. Okay, so that's a very important learning that you need to get from today, and I'll explain that to you later. But you get to a point when pretty much you're having as much disease or perhaps even less disease than adverse events being reported. So what your community will see the adverse events being reported more frequently than the actual disease. And as you know, because vaccines are so highly effective in controlling disease, for many of the diseases that we vaccinate against, they have pretty much been eliminated, not eradicated, but certainly eliminated from circulation. So lots of adverse events, not much disease, and that's when you can get loss of confidence and you can have an outbreak of your vaccine preventable disease. If there's a return in confidence, then obviously disease rates will fall. And then, once again, you're in the situation where you have adverse events being higher than adverse reactions. Okay. So I want to ask this question. How do we know anything is safe? No, surely not. I'm going to have to talk faster. I've got lots of discussion time. How did we know that your air travel was safe or that your car travel was safe coming to Cape Town? Anyone? Experience? Okay, lived experience. No, Tony, that's not the... Okay. All right. Okay, so how do we know anything is safe? This is the point I want to make, okay? It doesn't matter whether you're talking about vaccine safety, car safety, motorbike safety, doesn't really matter. Safety is inferred because of an absence of adverse reactions, okay? So this is the point. It's an inferred thing. And as you know, I mean, you know your air travel is safe because air accidents are uncommon to rare, okay? Similarly with whatever you want, car travel. So reactions are adverse effects that are caused or precipitated and or triggered by the vaccine, and that's actually what is in the vaccine. So the actual liquid, the actual true vaccine product substance, or by the process of immunization. So this is the process of actually sticking the needle into someone and delivering that vaccine. So this is a critical point. So you've learned two things here. One is that safety is inferred by the absence of adverse reactions, and the second, it relates to both vaccine and to immunization, and we need to distinguish between the two. Now, here's where the other conceptual issue comes up, and that's many of the symptoms and signs of an adverse vaccine or immunization reaction also occur in the absence of vaccination. And these events, unrelated to vaccination, we call the background occurrence. So take, for example, febrile seizures occur, 1 in 20 children. That's a background condition. Clearly, if you have a vaccine, it can trigger fever, can trigger a febrile convulsion. But if you have a febrile convulsion, say 10 days following a vaccine or 4 days, was that a background condition or was it due to the vaccine? You can take something like Guillain-Barré syndrome, occurs as a background condition. If you have a vaccine, how are those two events related? Now, surveillance is the detection of an adverse event, and we obviously need to differentiate an adverse reaction from a coincidental event. So those are very important concepts to understand. But there are three unique vaccine reactions that only occur with vaccination with no background rates. Now, who can name the three groups of conditions? So this is where it'll only be caused by the vaccine. There's no background occurrence. So if you have one of these reported in your system, then you obviously know that is vaccine. Can anyone think? No, so anaphylaxis can occur as a background condition. You can have anaphylaxis to a food just before your vaccine, which we have seen occasionally. So, okay, injection site reactions, I haven't actually included in that, but I'll take that as being one. I need to include it, so there are 4. Thanks.
Fever?
Fever, but remember, fever can occur as a background condition. So if you're just doing surveillance in a community, of course, there'll be a background rate of fever. When you introduce the vaccine, you get higher. Okay. Okay, yellow fever. Yellow fever vaccine can cause visitropic and neurotropic. All of your attenuated live vaccines can cause disseminated disease in someone who's immunocompromised. And if you grow that organism in that individual, then clearly you know that's vaccine. It's not a background condition. And examples of this would be disseminated BCG, measles, in someone who's immunocompromised. And the last one is with COVID, is this vaccine-induced thrombosis with thrombocytopenia, the VIT syndrome, okay? That is specific to that viral vector vaccine. Okay, so those are three conditions that will not occur outside of vaccination. So just to recap, vaccine is inferred because of the safety is inferred because absent adverse reactions. Reactions can be due to the vaccine or the immunization, and surveillance is differentiating the adverse reactions from coincidental events. So how do we detect adverse vaccine or immunization reactions? This comes down to the regulatory framework, and you need to understand that there's a whole set of regulation that really surrounds how we determine vaccine safety. And this comes from the 50s. So I was born in 1956. Okay, turned 68 next week. So look, when I was born, or the year before I was born, the polio vaccine was being rolled out. There was a Qatar incident where the polio vaccine was incompletely inactivated. We had 200,000 children receive the partially inactivated vaccine, 40,000 cases of polio, 200 children paralyzed. Imagine if that happened today. That's when there was no regulatory framework for drug or vaccine. Followed a year later by thalidomide. So again, these two incidents were the primary motivation to really regulate drug and vaccine. So as we know, there's a whole national regulatory system that would be in all of your countries, and that they really determine or look at vaccine safety throughout the life cycle of the vaccine. And these are all the individual components, but what we're going to focus on in yellow is the pharmacovigilance. All right, so pre-marketing phase and vaccine safety. The critical point to notice here is that with your clinical trials, because of the actual numbers that are enrolled, you do not detect adverse reactions which are rare, delayed, unexpected, occur in subpopulations, and occur with vaccine combinations. So it's very important to know that at the time of licensure of a vaccine, and this would be the same for drugs, that the safety data is incomplete. That's critical, and that is inherent in the way that we set up clinical trials. So even with COVID vaccines, which were large trials, there were still only 20,000 in each of the groups and 20,000 placebo. The HPV vaccine was licensed on 4,500 people who were vaccinated. So you can see that there's no ways, if you have a reaction that is, let's say, a rare 1 in 10,000, that you're going to pick that up with your clinical trials. So post-marketing is very important, post-marketing surveillance. And this is where we bring in vaccine pharmacovigilance, which is really the detection, assessment, understanding, and communication about adverse events following immunization. So we need to move on to what an adverse event following immunization is. And this is critical. If there's one slide to remember, this is it. Because an adverse, this is the official COMS or WHO definition, and it's any untoward medical occurrence which follows immunization and which does not necessarily have a causal relationship. So this is why an adverse event is not the same as an adverse reaction. So an adverse event is a surveillance term. You don't have to know that this is causally associated with a vaccine. You just need to know the vaccine was given, something happened which was serious, and this is what's going to be reported. So what does it involve? It can be a symptom, It can be a sign, it can be a laboratory finding, or it can be a disease. Now, the main mechanism in each and every country that you come from is obviously passive surveillance. So this is the passive reporting of an adverse event. Not always very robust. And this is just coming back to Hannele's comment about during COVID, how we were able to enhance certainly passive surveillance. But there are other mechanisms of surveillance, including active surveillance, individual case review, and epidemiological studies. We talk about the adverse event surveillance cycle, and I don't have much time to go into this, but essentially this really relates to the detection of an adverse symptom by a parent or a caregiver, notification to a healthcare provider. That healthcare provider has to report the adverse event. It has to be investigated, analyzed. We need to do causality assessment because an adverse event is not the same as a reaction, and then complete the loop with feedback. So how do we do, why do we do post-marketing adverse event surveillance? So in each of your countries, it's really stipulated as a minimum we should do adverse event surveillance post-marketing and not dependent on the region or the country next door. And there are three critical reasons to do that. Now, the first is to monitor the rates of known adverse reactions and compare the observed with the expected. So if you want to go back to your comment about fever, we would know that there would be an expected rate of fever with any vaccine that would have been determined in a clinical trial. Once you roll that vaccine out into your community, are the rates of high fever or febrile convulsions, let's say, we know post-measles, mumps, rubella vaccine, 1 in 3,500, is that going to be expected in your community? So that's where we determine that. And the WHO, for example, has given observed rates of reaction sheets to really sort of quantify those. The second reason is to detect a vaccine safety signal. So this is something that's previously unknown because as I've said to you, at the time of vaccine licensure, the information about vaccine safety is incomplete. And more science, okay. And so these are previously unknown events. And can someone give me an example? So even I mentioned that to you in COVID even. So I want to know, at the point of licensure, when did we license the vaccine, where once it was rolled out, we had a serious reaction that then came to light?
The first rota
Yes?
and interception.
Yeah. Okay, so if you look at the photograph on your left, that's a classic interception. So that was not known at the time of vaccine licensure of that vaccine. The middle one is the VIT, the vaccine-induced thrombosis thrombocytopenia. And the one on the right-hand side is myocarditis after the mRNA vaccine. So just three examples where at the point of licensure, we did not know that those adverse reactions exist. So that's why we report adverse events and not reactions, because if you only reported reactions, none of this would have been reported. So that's critical to understand that concept. And the last is to detect immunization program errors, and these can be extremely serious. So the photograph on your left is someone who was given, or in fact a whole community was given measles vaccine contaminated with staph toxin. And the next one is a diluent problem, whether the measles, mumps, rubella vaccine has to be diluted. If you mix up the diluent and put insulin in that diluent or a muscle relaxant, that can be fatal. So how do we differentiate an adverse reaction from a coincidental event? This is just simply to recap what I've been saying. And we need to talk a bit now about causality assessment. So causality is the relationship between two events, the cause and the effect, where the second event is the consequence of the first. And causality assessment is a process where we actually determine that relationship. So how do we know a vaccine has caused a reaction? So the first thing that we look at is within a population. So can it? does vaccination increase the risk of the occurrence of the event in that community? So that's the can it question. The next question is, did it? And that's when you assess the individual. So was the vaccine a factor in that particular individual in developing the particular reaction? So if we look at population, the first important thing to say is that passive surveillance does not establish causality, because you're looking at those who've had the vaccine and you're looking at those who've had the actual event. So if you look at your classic 4x4 table, for doing statistical comparisons, we're just filling one of those cells. But I've already said to you, there are four exceptions really to that, because if you have those particular events described, we know that's unique to vaccination. But that's very unusual, because most of the events won't be unique to vaccination. So how else can we do this? So we can look at background rates to establish causality, and that's within a population. We know who was vaccinated, who was unvaccinated, we know who had the condition and who did not have the condition. So you can see we can at least fill up two of those 4x4 tables, and we can look at our observed rates, and we can compare those to the expected rates. And the difference between the two, that top bar and the light bar, would be your vaccine attributable rate. The last way we can do it is really to do epidemiological studies, and obviously we then fill up all of those 4x4 cells. So we know who was vaccinated, who was not vaccinated, we know who had the condition and who didn't. And this really comes down to randomized controlled trials, or really observational studies, which are either cohort or case control studies. But essentially that's how we would establish causality. For the individual, there's a specific process within WHO that looks at how in an individual you would establish causality. And that's an individual review of the cases, and this is just a reference to those that information. But essentially, there are 4 steps to causality assessment. The WHO training for this, for example, would involve 3 or 4 days. So I'm just making you aware of the process, that there is a process that is published and recommended by WHO in order to establish causality. Essentially, once you've been through that process, you're really taking your adverse event case and you're fitting them into one of these 5 blocks. So this would either be vaccine related, so in other words, a vaccine reaction, and we're talking about vaccine product reaction. So this is what I said to you in the beginning, actually what is in the bottle. Vaccine quality defect, that's already been mentioned in terms of COVID vaccine, and this relates to the actual quality of the vaccine product, either a manufacturing issue related to that. Immunization, error-related reactions, so this relates to inappropriate vaccine handling, prescription or administration, immunization stress-related responses such as vasovagal events post-vaccination, and then differentiating that from coincidental. Essentially, the process would land us in one of these boxes, so either consistent, in which case we've got the 4 classifications, indeterminate, where we can't really determine this, or inconsistent, which is coincidental. So really just to finish up, one of the things that I've done for close to 3 decades now is run an adverse event clinic. So we actually in our hospital, if someone has had an adverse event or we suspect a reaction, they come to the clinic and then we can assess them clinically. So these are injection site reactions that I've accumulated through time, and each of them would have a different cause specific. So I'll just take you through them, going from the top, your left, coming through the other side, just to show you the different causes of injection site reactions. So the first one, immunization error. If you take an adjuvanted vaccine and you learnt about the adjuvant inducing an inflammatory response from your previous talk, and if you inject that vaccine too superficially into the skin, it'll cause a severe inflammatory reaction that'll cause quite a severe injection site reaction and even systemic symptoms. So that would be an immunization error. That's been given incorrectly. The second one is BCG adenitis that you may well have seen. And again, that relates to the way that the vaccine is given. If you take a BCG and administer it subcutaneous rather than intradermally, then 2 or 3 months later, you'll get a BCG adenitis. Vaccine product related, sometimes the actual reactogenicity of the BCG strain can change and again can cause BCG adenitis, which we had an outbreak of that related to BCG. Vaccine product, this is the top one on your right-hand side. You've got what we call extensive limb swelling. This is due to the acellular pertussis vaccine and usually occurs with cumulative doses. Dose 4 and 5 can often get quite marked swelling from the elbow really down to or up to the shoulder. Again, vaccine product, this is a hypersensitivity reaction or an allergic reaction. This is the bottom one on the left-hand side at the bottom, showing lots of urticaria and angioedema in relation to that injection site reaction. Immunization error, the next one along, those knees, this was a child who got a DTP vaccine into the bursa of the knee, of the right knee. You can see the right knee is swollen. So again, immunization error, vaccine administration completely incorrect. Coincidental is the next one along with those two patches. This one here, and this was a child who'd been vaccinated at those sites and then had a topical antiseptic put onto the vaccination sites and developed a contact dermatitis. So you see, it wasn't related to the vaccine or to the immunization, but coincidental due to what was put onto this. And then this shows really swelling of the limb, which comes from actually keeping the limb in a single sort of plane after vaccination. And that can cause pain and swelling of that limb, not due to the vaccine or due to the process of immunization. So just to show you that with an adverse event, we need to classify that into reactions, and reactions can be different subclassifications or subtypes. All of this information and much more is very well covered in the WHO site, and we'll give you a copy of these slides, and you can really have a look at all the resources, and they also include e-learning. So in conclusion, concerns about vaccine safety affect vaccine coverage. Safety is inferred because of the absence of a vaccine or immunization reaction. Pre and post-marketing surveillance of adverse events following immunization is the basis of pharmacovigilance. And causality assessment can be done both at a population level, but also at an individual level. And very important to differentiate, as I say, a reaction from a coincidental event. Thanks very much.
Thank you so much.
Sorry, I went over time.
No, it's fine. We're already behind.
Yeah.
We're already right.
Yeah.
So it's the schedule is already affected. So we will take 15 minutes questions from both online and the floor, and then we will go for tea break. And then when we come back, we will convene with Prof. Greg's talk. So I will start with one question. So you said at the time of licensure, they were not sure, like about 100% about the safety. So, but like we've seen also like the clinical trials during pandemic, like during COVID, how massive the sample size were, and they were like multi-countries clinical trials, like they were better than the like traditional vaccines. So do we really need like 10 years to be sure about the safety about
Sure. So I come back to the point. Even if you took the multiple trials, okay, and you added up all the numbers, it was still only 40,000. So if you've got a rare event, that still would not be being picked up by the 40,000. I think 20,000 of that was placebo still. So you do need the numbers. Now, so it's all a numbers game. Now, I worked out the numbers. So within 3 months of the COVID vaccine being rolled out, we'd reached millions of doses. So that obviously gave us those safety signals, the myocarditis and the thrombotic reactions presented very quickly. If you look at the timeline, literally within 2 months or so, people had begun to detect those adverse events and investigated them for reactions. Now, if you take the HPV vaccine, to use that number of doses, I think I worked it out to be somewhere close to 10 years. So can you see what I mean? So in a way, that's reassuring if you're rolling out a vaccine like COVID in large numbers, provided you've got a sort of semi-robust surveillance system, because you're just cranking over the numbers so much, you're giving such a high number of doses that any rare reaction is going to declare itself. And the way that the thrombotic reactions declared themselves really were to clinicians. So those were clinicians working in a clinic that actually saw these people presenting with these terrible clots in the brain and in the gut that had really only been described with heparin. And these were people who are not on heparin. So they immediately recognized this as something completely different.
Okay, so this time I know I will give you all a chance, but I will start with 2 questions from online, and we'll come back to the floor.
First question is, through your professional knowledge, Prof, do some countries have compensation programs for persons injured by vaccination? And the other question is, we also have adverse events of special interest. Can you say something about it? And when is AESI indicated for surveillance?
Right. Okay. All right. Great question. So just quickly, so the no-fault vaccine compensation, the best example of that was in the USA. Okay. So what happened is that there was so much legal liability to the vaccine companies that the government instituted a levy on the vaccines and said that if you experienced a known reaction, let's say anaphylaxis, so we know anaphylaxis will occur, say, 1 in a million to 1 in 100,000 vaccines. If you have that and are damaged by it, that's one of the compensatable conditions, okay? And you basically will get compensated for that, and then you would waiver your rights to legally sue the company. So different iterations of that have come into various countries, and particularly with COVID. Now, when COVID vaccines first came out, the companies actually wanted a legal waiver that they would not be sued by anyone if they provided the vaccines. So that made it even more complicated for governments to really provide some injury compensation scheme because we didn't know what rare reactions would occur. So this during COVID times did happen in certain countries. I'm sure it happened within many African countries. Perhaps I know it happened in South Africa. It happened in Australia. Australia doesn't have, for non-COVID vaccines, an injury compensation scheme. So it's a very vexed issue. So that's what I can say. It's very topical, and this generally covers what happens if you have a known reaction and you suffer damage from that. Because we know this will happen. If you vaccinate a population, there will be certain events that happen that will cause damage. I think the biggest one for the COVID vaccine was obviously the myocarditis after mRNA vaccine and the clotting reactions in the head. Now the AESI, this really comes from clinical trials. So clinical trials have always specified adverse events of special interest. When the COVID vaccinations came out, people thought, well, let's think about AESIs for COVID vaccines. So let's look at the platform, let's look at what's been described before, and let's set up surveillance processes for these AESIs. Now, the surveillance for that is event-based surveillance, not immunization-based surveillance, but it's event-based surveillance. So what this means is you say, go to a referral hospital, and you say, look, I'm going to look for myocardial infarction. Everyone who comes into that hospital is going to enter into the surveillance because that's an adverse event of special interest for me. And then I'm going to work out whether they were COVID vaccinated, yes or no. Okay? So the surveillance is based on the event, not on the immunization. So it's not an adverse event following immunization. It's an event-based surveillance. So that's a key difference between the two.
So to be just, we will take one question from here and one question from the other side. So I will start with here. So she raised her hand first, and then we will do like one here, one there, just to be just.
Thank you for the opportunity. So, Prof, you earlier on alluded to the issue of safety concerns about the newly introduced vaccines with COVID and mpox in some of our countries. So I'd like to ask, in your opinion, how do you think immunization programs can step up their either communication to address some of these safety concerns? As we all know, the safety concerns eventually affect coverage of these vaccines.
Sure.
Yeah. So in your opinion.
I'll just mention a few points briefly, because on Friday, there'll be a lot of talk about communication and how to communicate. So, I think it comes back to basic principles. I mean, about transparency. To say that the COVID vaccine, as many politicians did in all countries, including my own, was that the vaccine was 100% safe. Okay, but people know that that's not true. So, I mean, transparency is clearly an issue. Communicating about what you know and what you don't know is very important. Clear communication, outlining a plan of what's going to happen. I think what was mentioned earlier was the risk-benefit language and discussions, because remember that the myocarditis for the mRNA affected boys between 12 and 17. Now, their chance of having severe COVID with myocarditis was practically zero. You know what I mean? So you're giving a vaccine, exposing them to all the risk with very little of the gain. So, being much more nuanced about that communication is essential. But it's a vexed question, and we'll discuss that much more on Friday.
Okay. Thank you, Prof.
Oh, okay.
Okay, so I have two questions very briefly. My first question is on AFI regarding children that will have multiple vaccinations at the same time.
Yes.
So are we able to differentiate which vaccine causes? Yes, that's the first question. Now, second question is I want to ask about the role of genetics in AFI, because for instance, if you have a child that has had vaccine administered and developed AFI, and then maybe a younger sibling or someone comes after then, and are we able to differentiate if it's genetic related or whether it's just coincidental or other parts of the group of AFI causes?
Okay, great question. So, look, in terms of the genetics, I'll just cover that one quickly. So there are only three very rare adverse reactions that have been genetically linked. So it's a pity we don't know more about the genetics, because we know a lot about the immunology as it relates to efficacy and immunogenicity. We know very little about the immunology and the genetics as it relates to reactions. Okay, so the first one is a syndrome called Dravet syndrome. So it's a neurological condition. It gives you recurrent seizures, and those seizures are triggered by an inflammatory event in a baby. And that is usually the vaccine that triggers it. And then it goes on to severe and progressive. But it's actually the inflammatory response, not the actual vaccine. The second is the measles, mumps, rubella vaccine. And in Pacific Islanders, they have basically a form of inborn error of immunity. And that can give them disseminated measles vaccine disease. And the third one is with HLA haplotypes and narcolepsy after the influenza vaccine. So, I mean, they're all very rare conditions. You don't need to know about them other than to say that, look, that's how little we know, only those three conditions. Then the first question was the adverse event. Okay, multiple injections. So look, so parents often ask you this, and even healthcare providers. So the way that I answer that question is this way. I mean, we have billions of bacteria and viruses in our body. Our immune system is working 24/7 365. Okay, as you heard from Sarah, you would not survive unless your immune system was working. So really to add in, even if you add in 10 extra vaccine antigens with multiple vaccines, that's not going to overload the immune system, and it's not going to make the adverse reactions any worse. How do you distinguish which vaccine it is? Well, that's a really difficult process. It comes to the causality assessment process. And we actually say when you do the causality assessment process, you've got to do each vaccine separately. So it's difficult. Yeah.
Thank you. Okay. I have a question.
Yes.
During the pre-marketing phase, when it comes to clinical trials, how do you explain the safety of the vaccines to the participant, knowing that we don't know if it's safe? And we're still testing those vaccines, especially when it comes to children and infants, where we need the consent of the parents. How do you
Yes.
explain to the parent that we have to vaccinate your children, but we are still testing these
Yes.
vaccines?
Yes. So you're talking about within the context of a clinical trial or in the context of an immuno?
Clinical
Yeah.
trials.
Yeah, look, it's informed consent. So look, I mean, as we know, phase 1, risky. Phase 1 trials are all about safety in few individuals. Then, you progress to phase 2, which is a bit of a combination between, safety and immunogenicity, and then phase 3. But you're right, it all comes to informed consent. And clearly, for it to go through an ethics committee, clearly they would have to see all the preliminary data, particularly with regard to anyone, but children, that relates to animal model, phase 1 studies, phase 2, etc. But yeah, look, I think there's no way around it. That's just the process that we have, and it comes to informed consent and ethics committee, obviously.
Hi, thank you so much for the great presentation, Prof. So my question is, I'm just trying to understand what the difference between an adverse reaction and an adverse event. So during COVID-19, when people were getting the mRNA vaccine,
Yes.
there was a reactivation of the herpes simplex virus where they got like cold sore on their lips. So I'm just trying to understand if that is an adverse reaction or an adverse event. Would an
Okay.
adverse event be an accumulation of adverse reactions? Or-
Right.
Yeah,
Yes.
that's my question.
Sure. Okay, so we can use that as an example. So the adverse event is a surveillance term. Okay. So you were giving the mRNA vaccine and you were noticing, say, within 7 days, people were presenting with activation of herpes, cold sore. Okay. So you would report that as an adverse event. I mean, you gave the vaccine, something happened, it was unexpected, should be reported. So you report that as an adverse event. Now the question is that a reaction? Was A related to B? Was giving the vaccine related to triggering of the herpes? Now, in order to do that, you've got to come through to the slide which I said. You would look at that at population. So could it do this? And there you need further epidemiological studies. Okay? So you would have to do further epidemiological studies, look at a vaccinated, unvaccinated group, and see whether breakthrough herpes is more likely after vaccination as opposed to just the background condition. Because, obviously activation of herpes is a background condition within the community. If you proved an association statistically, an increase in relative risk, then you could say that that moves from an event to a reaction. Okay, and it's probably there are two kinds of reactions: the direct reaction, which would say be anaphylaxis, or the reaction where it would trigger that event. So let's say febrile seizures. In order to have a febrile seizure, you've got to have something. You've got to be different as a 12-month-old child to someone who doesn't have a febrile convulsion. There must be something genetically different, or there must be a predisposition to convulsion. So the vaccine is acting as a trigger. So it's sort of biologically plausible that if you had a vaccine, it could trigger cold sore, obviously.
So we'll take one more question online. This is from Gordon Amo. He's asking, how will you situate the concept of nocebo effect in the context of adverse events?
Okay, fantastic question. So does anyone know what the nocebo effect is? Have you heard that? Because this is quite topical. Does anyone know what nocebo effect is? Okay, all right, good, because you can learn something. So placebo is when you give something and you expect a positive effect. Okay? So placebo effect, you take any intervention, okay, and there'll always be a placebo effect. So if you give any drug and you compare that to a control, you'll get a positive effect, in 10 to 20% of the population. So if you want to know whether your drug or your, vaccine or whatever works, your intervention, you've got to be better than the placebo effect, okay? The nocebo effect is when there is a belief that it's doing you harm, that's giving you harmful symptoms, okay? So it's the opposite of placebo, all right? And we know that there is a nocebo effect, and they've even looked at this in the context of the COVID vaccine and COVID trials, because they've just taken the placebo group and looked at the reporting of adverse events in the placebo group. What I wouldn't say placebo group, but I'd say the ones who got the comparator, let's say the nothing, compared to the vaccine, and they've reported adverse symptoms. So that's called the nocebo effect. Now, where this comes into play with vaccines is in relation to that one category that I called immunization stress related responses. So this is related to the process of immunization, okay? And let's take a very good example of that, and that was I'll come back to COVID vaccination again. So for COVID vaccination, do you know when the first COVID vaccine was given? Okay, it was given in the UK on the 6th of December, okay, 2019. 2019. Yeah. Sorry, 2020. Yeah. So within 24 hours, you remember all those issue about anaphylaxis, and basically they had statements in the UK saying that they virtually had to suspend the entire program, or anyone who had any allergy of any sort could not get the vaccine, the COVID vaccine. Okay, and that was reported from the US as well by the CDC in the January. So we're talking December 20, January 21. Again, this huge case series, and they thought the rates of anaphylaxis were tenfold higher than what was expected. Let's take 2 years down the track. Let's understand that. So basically, when you looked at the cohort that were being vaccinated, they were largely healthcare workers. They were largely female because they were essentially nurses. And those that were presenting with anaphylaxis symptoms were those who'd had previous allergies and anaphylaxis. And when you really looked at those cases very carefully, and even revaccinated them with the same vaccine and they didn't have anaphylaxis, they were presenting with these immunization stress-related responses. So they had a nocebo effect. They'd had anaphylaxis before to something else. It was a very anxiety-provoking time. This was a new vaccine that no one knew what it would do and wouldn't do. There was a lot of, obviously, social pressure, etc. And they presented with a nocebo effect and with symptoms which were mimics of anaphylaxis. And in fact, when you discounted those, the rates of anaphylaxis were no higher for the COVID vaccine as opposed to other vaccines. So a very good example of the nocebo effect.
Thank you, Prof. I think this is going to
We can go on forever, but I can say at 5 o'clock if anyone's interested.
Yeah.
I'm happy to carry on speaking.
Yeah. So, but now, do you want to go for other additional 5 minutes questions or go for tea? Which means that tea will be 15 minutes, not 20 minutes. So you decide. Questions or tea? No. Who wants question? Raise hands because. No. So Prof is available at 5 if you have additional questions.
Yeah.
Okay. Thank you so much and let's enjoy tea.
Offer to say that he's willing to do a workshop at 5 o'clock on adverse events. So if you are interested, there's going to be a paper going around, and I think it's a wonderful opportunity to take up. So just the paper will come around. You can put your name down if you're interested for the workshop at 5 o'clock. And then Professor Greg needs no introduction. Greg, I'm going to give over to you.
Thanks, Chrissy. So Mike, we should have had the continuation of the lecture now, because what I'm going to do is just give you a history lesson. So, but history is important, and as Mike said in his presentation, he spoke about the process of variolation with respect to smallpox that's been prevalent for over 2,000 years. And Adina's leaving now, but Adina, we exported our innovative practices with respect to variolation to the Americas. So the Americans are not the founders of vaccinology, the Africans are. That's just as an aside. So I'm going to be quite brief because we want to play catch up, and the slides will be made available to you. They are self-explanatory. It's not rocket science. I'll cover some of those issues in terms of history, evolution of global programs, schedules, etc. And this makes for interesting reading. As I said, we don't know about Africa's contribution to vaccinology in general. And in fact, this is what a slave taught Americans, the principles of vaccination, going back to 1706. So go and read about the African origin of vaccination. There's some, I've given you 2 references for that. Just briefly with respect to smallpox, we know that, as Mike said, Jenner developed the cowpox vaccine to prevent smallpox in 1796. And as a matter of interest, many countries in Africa were developing vaccines for smallpox in the late 18th century. And I've got a list of sites in Senegal, Guinea, Ivory Coast, and so forth. So in terms of indigenous vaccine capacity development, that was happening then already on the African continent, and much of that obviously has demised. And on the right-hand side is just the slide showing you, going back to the 40s, the impact of smallpox vaccination in reducing the incidence of smallpox in West Africa. The same with yellow fever. As you know, yellow fever, the vaccine was developed by Max Thiele in 1937. And Max Thiele is a South African, and he received the Nobel Prize in 1951 for his work on yellow fever vaccine. And on the right-hand side, you can see, going back to the 40s, 50s, the impact of yellow fever vaccine in reducing yellow fever in Africa. Quite a significant advance. And then with respect to TB, BCG vaccine, BCG vaccine was used in the 20s, 30s in West Africa, where TB was a significant health problem, and they expanded to the rest of Africa. When you look at the evolution of vaccine development over the years, and this graphic just shows, going back to Jenner in 1796, that in that 130 years up to about 1930, there were 9 vaccines developed, which equated to about 2 vaccines per year. And if you look more recently, from 1990 to 2020, there were 40 vaccines developed in 30 years. And the evolution of vaccines was as a result of the development in terms of modern biotechnology. This slide just shows you, it's a UK example. It's the historical development of vaccines and the introduction of routine vaccine programs in the UK. And as we spoke yesterday about typhoid, you'll see first typhoid vaccine actually made in 1896. Okay. Just a few minutes on the vaccine life cycle. I'm sure many of you know this, but for those who are not familiar, we spoke earlier on, there's a question to Mike about vaccine trials. This is the vaccine life cycle a la the US model, which we try to replicate in most countries. Some countries are good at having review boards, others not so good, and that's why we have regional oversight as well. So essentially there are three, excuse me, there are three parts to the vaccine life cycle. It's the discovery, development, and the sort of what I call the delivery policy side. And if we go back to the discovery side, we're talking about the preclinical phase, and this is where the basic research. Oops, sorry. The basic research is done, and once you have a potential vaccine that shows promise in preclinical phases, then goes into clinical research, and essentially that's divided into three phases: phase 1, 2, and phase 3. And phase 1 is essentially safety, immunogenicity, involving around about 50 to 100 participants. Phase 2 is extended safety, immunogenicity, and potentially dose ranging and a few other factors. And that is involves usually about 100 to 200. And then phase 3 is in fact the actual stage where you are looking at efficacy. All right. And once you found a vaccine to be safe, effective, it then goes through different approval mechanisms in the States. It goes through what is an FDA approval and then the ACIP approval, and it's then approved for use in a population. I showed you the slide yesterday, looking at the vaccines currently recommended by WHO for immunization, and they're the universal recommendations and the regional or at-risk recommendations, and they're around about 13 universal and 14, 15 at-risk recommendations. And if you're looking for information, thanks, Chrissy. If you're looking for information on a vaccine, your first port of call should be the WHO position paper, all right? If you read nothing else, you know, Google rotavirus WHO position paper or typhoid WHO position paper, and that position paper will tell you everything about the disease, the epidemiology, et cetera, the pathogen, and the vaccine or vaccines that are available to prevent that disease. Right, and it would include issues around immunology, issues around, importantly, around indications, and issues around side effects. So if you remember nothing else, just remember that there is the WHO position papers for every single vaccine that's been licensed for use. There's the example of the malaria WHO position paper, which was updated in March 2022. So when we talk about the evolution of global immunization programs, I mean, it goes back to the 50s when the World Health Assembly passed a resolution to eradicate smallpox. And we know subsequently that in 1979, the World Health Organization declared the eradication of smallpox. And it's interesting to look at when the first schedule was developed or proposed, and that goes back to about 1961, when WHO proposed a schedule for vaccination, which included smallpox, diphtheria, pertussis, tetanus, BCG, polio, and typhoid vaccine. And this makes for interesting reading, because they had two schedules. One schedule that was recommended for areas with adequate public health medical services, okay? And interestingly, they recommended polio virus vaccine for that group of people. Then there was another schedule that was recommended for areas with inadequate medical services. And polio wasn't recommended there because they assumed that everybody got polio in those situations, but they did recommend BCG vaccine and typhoid vaccine. It just makes for interesting reading in the context of the historical evolution of programs over time and the issues related to equity. So as we know, the expanded program on immunization was launched in 1974, so that's 50 years ago, and was built on the success of the smallpox eradication program. And the objective then was to increase the immunization coverage for essentially 6 diseases for which vaccines were available, and that included BCG for TB, diphtheria, pertussis, tetanus, polio, and measles. And at that stage, it was estimated that the global coverage rate was less than 10%, all right? And the strategy recommended then was through routine immunization services. The concept of the expanded program of immunization has been amended to what is now called the essential program on immunization. And that this idea of the essential program on immunization is based on the fact that we need to shift the paradigm from immunization being essential not only for children, but for everybody throughout the life course. And Tony will talk about the Immunization Agenda 2030. And central to that is the life course immunization program. So in terms of governance of our immunization programs, there are essentially 3 essential components. The one is we have at a global level, we've got the strategic group of experts. At a regional level, we've got the regional immunization technical advisory groups, and we have the RITAG for the Afro region, and then we have national immunization technical advisory groups. And as we heard at when we had the introductions, there were 1 or 2 people in the audience who came from NITAGs. I'm not going to talk about how services are delivered. We know that services are delivered routinely through fixed clinics, outreach sites, mobile teams. In special circumstances, we have what are called supplementary immunization services through mass campaigns, catch-up vaccinations, and outbreak response campaigns. And you can read up around that. And this makes for interesting discussion as well, because many people have promoted the concept of mass campaigns, and others have argued that mass campaigns, in fact, impact negatively on health services generally, especially in situations where health services are fragile, which is so in many parts of Africa. This is just looking at the evolution of the global immunization programs over time. We started in 74 with the expanded program of immunization. We've had various iterations of this program, and we're now sitting with the Immunization Agenda 2030, which will be talked to by Tony later on. And I've given you some references for these various initiatives from 74. I was going to talk about Gavi, but there is a talk on Gavi, in fact, after this. Anyway, there's a talk on Gavi which will happen sometime later today. So I'm going to skip the Gavi presentation. As today, we have 54 countries that are supported by Gavi. Those are the countries in Africa that are supported by Gavi. Gavi has made a significant impact in Africa in terms of supporting immunization programs, and Gavi is moving towards supporting middle-income countries as well. Right. There are a whole list of immunization initiatives which we don't have time to talk about. Just important to note, you saw an iteration of the slide yesterday in terms of the zero-dose children that predominate within the African context, both in West, Central, and East and Southern Africa. And there are big programs trying to look at how we can reach those zero-dose children. And these programs are led by WHO, Gavi, and other agencies. All right. I'm not going to talk about schedules because we don't have time. But that's a definition of a schedule which you can read around. And the reason why schedules are important are essentially fourfold. It provides a framework for delivery of vaccination. It allows us to monitor and evaluate coverage and impact. It's important for research and development, and it's important in the context of the communities we serve. All right? And it's a compromise. I mean, there's no rocket science behind schedules. It's a compromise. All right? And the age of vaccination depends on a whole host of factors. The risk of disease, the maturity of the immune system, vaccine safety, reactogenicity, et cetera, right? One question to you, because I've been talking for 15 minutes without a break, is virtually every single vaccine we have today, we have to give more than one dose, as you heard this morning, because we have to generate secondary immune responses by repeated doses, and immunity tends to decline. Can you name one vaccine that requires a single dose? BCG is given at birth, but some people would recommend that you need to give a second dose in adolescence. Yellow fever, yeah. Yellow fever is a vaccine that is given once only, and you don't need another vaccine dose. It used to be every sort of 10 years, but I mean, that's been done away with now. And then obviously HPV, but we still need to learn over time whether that's going to be sufficient to protect young girls for more than 10 years. But as a strategy, a single dose in the immediate future is a good idea. And also in terms of, we spoke yesterday about the single dose cholera, but you're going to need more doses eventually. All right. These are just examples, and you can check on the WHO website. That's the summary of the position papers for routine immunization. It talks about when the vaccine should be given, the spacing of the vaccines, et cetera, et cetera. The primary series generally is similar in many countries. So you can see that Africa adopts a 6, 10, 14-week program compared to other countries that adopt a 2, 3, 4-month program. And it's really convenience. And the idea behind the African program is to try to get the vaccines in as early as possible to protect those young babies from morbidity and mortality from vaccine preventable diseases. That's our schedule at the moment in South Africa. And you can look at that at your leisure. We are now introducing rubella, and we should be introducing birth dose hepatitis B, which is happening in a selective manner. And as I said, the paradigm in the past is focused on infant, young child immunization. We need to change that paradigm, that way of thinking in terms of expanding immunization to other age groups. You're going to have a talk on vaccination of pregnant women later this week. You're going to have a talk on life course immunization as well later this week. And that's in the context of the Immunization Agenda 2030, which Tony will talk to. So that's the bottom line. All right. Thanks, Chrissy. I hope I've made up some time.
Thank you, Prof. That was brilliant. Thank you.
And there are not going to be any questions. You can post me an email.
We're actually going to hold all the questions for the end for all the speakers. So the next speaker is Dr. Anthony Hawkridge. He's well known within pediatric and public health spaces, and we are very blessed to now have him with VACFA as well. So Thank you, Tony. Tony's going to be speaking on the Immunization Agenda 2030. And it's up to you. Thanks.
Thanks, Chris. And you're very kind. Can someone help me find the presentation? Oh, there we go. So, am I correct? I've got 20 minutes. About that. All right. So
just give me 1
so
second.
we're going to have to speed up from sort of 50 kph to about 120. Okay, thanks. All right. So this is actually Ben's talk. And so just to give him credit, but he's allowing me to give it. And my name's Tony Hawkridge, and as Chris said, I'm part of VAC for now. This is not appearing to move. There we go. All right. So those are Ben's disclosures. The only one I could think of is that I'm a non-executive board member of IRV. I don't think that's going to make too much difference. And really what we're going to do in 20 minutes, this is like Greg said, his talk wasn't rocket science. This isn't rocket science either, but it is something that we need to know as vaccinologists, as vaccine advocates. So there are two publications which look a bit daunting. The first one is 60 pages long, the other one's 32 pages long, but actually they're fairly easy reading. And they've got lots of pictures and lots of graphs and so on. So do yourself a favor, download them, go through them at your leisure, and just make yourself familiar with them. But I'm going to be talking mainly about the first one and then the second one in some of the later slides. So it's divided into 5 sections. So firstly, like any good strategic plan, Greg's covered some of the history. I'm not going to talk about that. It has a broad vision and an aim. I'm sure most of you work in health departments or for big organizations, and you've got long-term strategic plans. I can tell you in the Western Cape, we've got something called Healthcare 2030. It was originally supposed to be Healthcare 2020, and then it became 2030 and announced 2050. And these are great documents, and it's very important to have them. But the point is that they take quite a while to write, and by the time they're published, often things have kind of moved on. So that's the nature of strategic plans. But it's ambitious. It says it was collaborative, so it took into account the opinions of a wide range of stakeholders. So hopefully some of you were consulted when IA 2030 was written, and an effort is made that it's real. It's a real document, speaks to real needs. It speaks to countries which really are struggling with inequity and inequalities and so on. And lastly, it draws on the lessons of previous campaigns, previous disease-specific initiatives, and tries not to make the same mistake again. It's not reinventing the wheel and hopefully not making the same mistakes. So that's what it looks like. Go to the website, you can download it. It's not too bulky. Right, there's the vision. Very broad, as I said, very aspirational. Everyone, everywhere, every age, fully benefits from vaccines. Good health and well-being is not just prevention of illness, but actually promotion of good health. And with this lofty target of 50 million lives saved by 2030, it's got these 3 impact goals, and attached to each of them are targets. So there are some of the targets, and you'll see more of them in the last slide. And this is a diagram that you'll see a lot in the slides and in the publication. And just to explain, down the bottom there are 4 core principles, and up the top there are 7 strategic priorities, which is a bit confusing because you can count 6, but actually the one in the rainbows is the 7th one. All right. So here's the 4 core principles: people-centered, partnership-based, data-guided, and country-owned. And those are phrases that you'll see come through in a lot of WHO, UNICEF, and other documents. Those are good things. You know, we want to be thinking of our communities when we write strategic documents. We want to be thinking partnerships rather than going it alone. We want everything to be data-led, data-guided, data-based, and we want it to be locally relevant and contextualized for our countries. Okay, so that's vision and core principles. In the strategic priorities, as I said, there are 7. They're listed there. I'm not going to read them out. And the slides that you'll get and go through each of them. So I'm not going to read them again because we don't have time. But the first one is on programs. Okay, and for each of them, you've got the goal, the objectives, and the key focus areas. So Program 1 is about leadership, the workforce, surveillance, supply chains, information safety systems. Okay. Second one is about commitment and demand, and trying to generate demand for our vaccines so that people want our vaccines and actually come and demand them from us and hold us accountable if we don't deliver them. All right. So it's about commitment, support, and seeking out. The third one is about coverage and equity. Greg spoke a little bit about equity. So getting our immunization to everyone, regardless of location, age, socioeconomic status, and gender-related barriers. So that's aspirational as well. Greg spoke a little bit about zero-dose kids. And then the fourth one is about life course and integration, big emphasis on that. So it's not just a focus on infants and young children anymore. It's even old people like myself, Greg, Mike, and a few others. All right. Objectives, strengthening policies, delivery, catch-up, boosters, integrated delivery, and the different age groups. The fifth one is about outbreaks and emergencies, and we had a wonderful lecture yesterday from WHO on that. But the ability to anticipate emergencies, prepare for them, detect when they're happening, and respond effectively, and particularly looking at populations and areas where there's a lot of conflict, disaster, and humanitarian crises. And I've updated this from Ben's one. So this was, I think we had a similar slide yesterday, but the reported health emergencies to WHO, not just in Africa, but across there. And you can't see Australia there, Mike, but I actually had a look just now, and I'm pleased to tell you there were none reported in Australia. All right, sixth is supply and sustainability. We tend to forget, as clinicians, we tend to forget about the supply chain and the cold chain, and obviously to our own peril. So ensuring that there's a reliable supply, appropriate, affordable, quality vaccines getting to our communities. And the last one is about research and innovation. And it's wonderful to have Heather Zah here, because she's one of the best researchers and innovators that I know. And we're going to have a wonderful talk on RSV just after this. Okay, so that's the strategic priorities. And then the framework, you've got to go to the second publication there, because it's detailed in there. It's got a framework for action and a nice way of setting out the different operational elements here. They're explained in this slide. So it's operational planning, M&E, ownership and accountability, communication and advocacy, and how they fit together. And this slide makes the point that that these things are put up there as a general sort of framework, but that there has to be flexibility, because every country is different, and every province within a country is different, and every district within a province is different, and you can't just have a one-size-fits-all and expect everybody to do everything exactly the same way. So there has to be some room for flexibility and for it. Remember, there were 3 impact goals, and from that they derived 7 impact indicators, and we'll talk a little bit about those. And the strategic priorities, there were 7, and from that they've got the objective indicators. All right, so this is from the impact indicators. And this slide requires a little bit of explaining, but the 3 big ones were preventing disease, promoting equity, and building strong immunization programs. So for each of those, they've broken them down into various components, and then come up with indicators and targets. All right, so I'm sure those of you who work in health departments, you're very familiar with indicators and targets that you have to report on every month. And if you don't make them, please explain, and every quarter and so on. And I think if you read through these, you would agree with me that some of them are pretty aspirational. You can't see probably very well, but there are some footnotes there, and it's important to read them. So, for example, that first one, number of future deaths averted through immunization, the footnote reads that this includes the antigens Hep B, Hib, HPV, Japanese encephalitis, measles, Men-A, streptococcus. It gives you a whole list of what about. So they do define it a little bit more carefully than that broad thing there. All right. Okay, and this is the really cool part. So if you go to this URL, which is part of the IA 2030 website, but it's a scorecard. They've got this live scorecard that you can go to, and you can look at it from a global perspective, and it tells you how we're doing as a world. In terms of the three targets that they put up, the three main targets there. And the key here is that if it's got a blue tick next to it, we're doing okay. If it's got an orange exclamation mark, we're in trouble. And you can see that most of those there, we're not doing so good. And then what's really nice is you can drill down to country level, and it'll give you a snapshot of your particular country. So being South African, I had a look at South Africa, and unfortunately there's not too much blue there, and there's quite a bit of orange. And I think it gives you the number of zero-dose kids here somewhere, which I was quite horrified to see. They estimated it over 2,000 or something. It was so. Anyway, you can go in for your country, have a look, and they do make disclaimers. They say this is based on the following data, and it may not agree absolutely with what your EPI is saying or what your health department or your health ministry is saying, but this is how we derived it, and this is why we think it's true. So they're trying to be transparent about it in order to generate action and generate discussion. Yeah, there's the zero-dose children. So that's for the next one. The 500 vaccine introductions, I was a bit shocked to read at first, but it's not talking about 500 different antigens or 500 different vaccines. So if I introduce one new vaccine into one country, I guess that counts for one. So it could be the same one in lots of different countries. And then for building strong programs, those are the indicators there. And then for the strategic objectives, they've got, again, a whole list of indicators and targets that they've come up with. And you can read them there, so I'm not going to go through them. All right, so we're almost done, and I'm just about in time. So the conclusion, so here's some good news, because that didn't sound like really good news. But what I did this morning was updated Ben's slides with today's data, because last time they were given was 1 year ago. So if you'd attended the course last year, that fourth block would have been missing, and it would have looked extremely gloomy. So the number of zero-dose children in the African region would have gone from 6.17 million to 7.3 to 7.3, and it was stuck there. So that was terribly, and it looks like it's come down in the last year. So I'm not sure why, but at least that's some good news. The bad news is it's still 9% over what it was at the baseline, and we're nowhere near getting down to our target of 3.09, which would have been a 50% reduction by 2030. So it's a very sobering document, scorecard and a website to visit, but I think it's well worth it. All right, I seem to have, yeah, there we go. And this is the last slide, which I think Ben was just trying to make the point that we have so much still to do. You know, I think yesterday the point was made that I think Ben made it. Vaccinology is such an exciting area to work in. It's such a positive area because we're doing so many great things, and we are. But we've still got so far to go when you look at maps like that. And that's it.
Thank you, Tony. You did so well that we actually have time for questions for you and Greg. So,
Greg is now open for questions.
okay, so what we're going to do is, Imen last time took the first question from online. So we'll take the first question from Bev, and then we'll go to an online question if there are any, to be also, if you could just check. So Bev.
So thank you very much, Tony. It was a great talk. So what's happening in South Africa with zero-dose children, and how are we going to fix it?
The short answer is I'm not sure, but the good thing is that there are people in the room who should know a little bit more. So I'm going to go to one of them.
Thank you, Tony. So I am the Western Cape coordinator One of the positive things that we have in place in the Western Cape is we've got contracts in place with about 300 public-private where we provide them with the vaccines and we get the data or the statistics back. The other provinces in South Africa doesn't have that. We are looking at dose cover for public health for all patients under 1 year fully immunized, but we only collect data for public, not for private. So there's a big discrepancy. Also, we are currently using the 2010 national survey. We have found in the Western Cape that our live births are declining, but our census population denominator that we use are actually increasing annually. So there's a big gap between the actual figures denominator that we're using and the survey denominator. There was a national survey done last year by WITS funded, where they were trained field workers were going door to door, where they were actually looking at road to health booklets and having an interview with the clients on why were certain vaccines missed. The Western Cape looked exceptionally good in the survey, in the outcome. I also know that the field workers often didn't get access to your more affluent households. The people would either be at work or whatever, or not willing to open the door for the field workers. So there's gaps. But in that survey, the feedback on why zero dose, what were the gaps, were actually identified. And I think learning from outcomes of studies like that plays a big role on the way forward. Thank you.
Thanks very much, Sonia. I think there was also someone from Mpumalanga. Who was from Mpumalanga yesterday? No? I remember in the introductions. Yeah? Do you want to tell us what you're doing about zero-dose kids?
Thank you very much for the opportunity. Unfortunately, we haven't started with the... it's one strategy that I've learned today, that they've contracted private people to give the vaccine so that they can get the data. But we do we have mobile services that go to the hard to reach areas, because in Mpumalanga we have a lot of mountainous areas where those people are not able to go to the facilities to get their vaccines. So we use our mobiles to go there, and also the community health care workers, they do and get the children, because they're not supposed to vaccinate. So they get the children to come to the facilities for them to be vaccinated. But we have already started with the coverage of the...
Thanks very much. So for those of you who don't know South Africa, Mpumalanga is the province up there by the Kruger Park, and it means the place where the sun comes up. Yeah.
So we have one question here I think this is to Tony. Why is the immunization agenda only focused on improving access and no mention of improving utilization? Duncan says he feels like improving coverage is a product of both accessibility and utilization. And yet the PHC definition talks little about utilization. So he feels that most of the issues of poor coverage are due to utilization issues and not necessarily accessibility issues.
It sounds like a question for Greg, actually. This is a higher grade question, Prof. So utilization versus, yeah. So I think the gist of it is we can get very bogged down in the numbers, and we have these eternal wars in our department about, have we got the right denominator, have we got the right numerator, and everything's focused on a number, a percentage, and you live or die by that percentage. And I think what utilization is what's important at the end of the day is not the number, it's whether the antigen gets into the arm and the child gets protected. And that is, I think, yeah. I don't know, Craig, do you want to add it? That's my boss.
No, I think, if I understand the question correctly, it's about how do we get people to accept immunization, and how do we get people to utilize and access the services? I mean, that's basically the bottom line. It's you can't constantly blame the services for not providing a service. You also need to look at the individuals that services are geared for, and how do they access the facilities.
Try to get our remote speaker.
Thank you. I think I just wanted to know from your perspective, and I know it's a lot of information, a lot of disagreements coming, agreements and disagreements coming in the next years. But what is your take on making 500 vaccines available?
So this is a reference to that target of the introduction of an additional 500 new vaccines. So just to repeat what I said, so that could be a country which is not yet giving, let's say, PCV and introduces it, that counts for one. Or it could be when our friends at SATFI give us a new licensed TB vaccine, that then hopefully goes to all countries, and then, we get 50 or so. 500 by 2030, I think it'll depend a lot. I mean, something like malaria coming online or TB coming online or a new HIV vaccine or something like that could bolster those numbers. But if it's little bits and pieces, 1 year, one there, it seems a little bit aspirational to me, maybe.
Thank you, Tony and Greg, and thank you for all the questions. Salim, are we okay for the next speaker? Yes, okay. So our next speaker is going to be remote. Her name is Michelle Jimenez. She's coming from Gavi, the Vaccine Alliance. Sure, let me move away from the thing. So she's going to be speaking on Gavi funding models, supporting sustainable immunization programs in Africa. Are you going to project her?
Hello, everyone. Hey, good morning. Just give me a sec while I set up my slides.
Have you got online?
You hear me?
Yes, thank you, Michelle.
Okay,
So I'm
great,
going to
good.
hand over to you. If you could just give a brief introduction and then you can go for it. Thanks.
Of course. Thank you very much. Good morning, everyone. Thank you very much for having me. I am sorry I'm not joining you in Cape Town on this occasion. But thank you very much for the invitation. I will be speaking on Gavi funding models and supporting sustainable immunization programs in Africa. I'm Michelle Jimenez, and I'm Senior Manager in the policy team at Gavi. So over the next 35 minutes or so, I hope to speak to you about Gavi's mission and work, describe some of the approaches and challenges to achieving vaccine access, describe the different types of support that Gavi provides to countries, and describe our new strategy and as our future agenda. I hope that we have a time for questions as well. So in terms of Gavi's mission and work, the important thing to remember is that Gavi is an alliance. So it is a public-private partnership that helps vaccinate half of the world's children against some of the world's deadliest diseases. The alliance brings together implementing country governments, donor country governments, as well as the World Health Organization, UNICEF, the World Bank, the vaccine industry, technical agencies, civil society, the Bill and Melinda Gates Foundation, and other private sector partners. Gavi's mission is to save lives and protect people's health by increasing the sustainable use of vaccines. After 2 decades of progress, Gavi is now focused on protecting the next generation. Above all, zero-dose children who have not yet received even a single vaccine shot. The Alliance employs innovative finance and the latest technology from drones to biometrics to save lives, prevent outbreaks before they can spread, and help countries on the road to self-sufficiency for their immunization programs. Gavi also plays a role in improving global health security by supporting health systems, as well as global vaccine stockpiles for Ebola, cholera, meningococcal, and yellow fever vaccines. Since the year 2000, when Gavi was funded, Gavi has helped vaccinate more than 1.1 billion children through routine programs and supported more than 1.9 billion vaccinations through preventative campaigns. And this has contributed to saving more than 18.8 million lives. And by preventing illness, death, and long-term disability, vaccines save money for families, communities, and countries. Between 2000 and 2023, our work has helped generate more than $250 billion in economic benefits in the countries that we support. It is also important to note that during this period, 19 countries have transitioned out of Gavi support, and I will describe in a bit more detail in a future slide the co-financing model that has allowed this to happen. So 1.1 billion children immunized, 69 million of those in 2023 alone. And this graph shows how that number of children has increased over time. It also shows how the number of vaccines that Gavi supports has increased over time in this green bar here at the bottom, as well as Gavi's budget has also increased to ensure that more vaccines can reach more children. In terms of Gavi's impact, there has been a significant drop in child mortality. The graph on the left there shows a 70% reduction in vaccine preventable deaths from the year 2000 to the year 2017 in Gavi supported countries. And on the right, we can show a 50% reduction in under 5 mortality in these same countries, which vaccines have been a significant contributor over this very similar period. Gavi has also closed the vaccine gap between lower and higher income countries. And this graph here shows coverage rates for 3 key vaccines and compares them between Gavi supported countries and non-Gavi supported countries. So in 2010, the coverage rates for Hib3, pneumococcal, and rotavirus were significantly lower in Gavi supported countries. By 2023, this had been reversed, where coverage rates were higher in Gavi supported countries than in non-Gavi supported countries. He also has an impact by shaping vaccine markets and has been able to reduce the cost of immunization, making vaccines much more accessible to Gavi, but also to countries. So this graph here shows the cost of immunizing a child with pentavalent pneumococcal and rotavirus vaccines and how this has decreased from $35 in 2010 to $15 in 2022. And as I mentioned briefly before, Gavi's portfolio of vaccines it offers to countries has grown significantly over time. And the bars here on this graph, or the columns, I mean, reflect Gavi's strategic periods and the different vaccines that have been added at each of these time periods. We currently provide support against 20 infectious diseases and already have approval from our board to provide vaccines against RSV, and we are currently developing updated investment case to make this happen now that there's a SAGE recommendation. But we also have approval to provide vaccines against TB, Group B streptococcus, and dengue when these become available, as well as stockpiles for hepatitis E and Mpox. And now I will move on to the second part of the presentation, which focuses on approaches and challenges to achieving access. And Here, I would like to describe briefly Gavi's model, which has a unique way of pooling vaccine needs and creating a win-win for both manufacturers and countries. So with Gavi, there's predictable demand and funding that have enabled the reach to more children with more vaccines. This has led to a significant increase in the number of vaccine doses produced. So from 50 million doses produced in 2001 to over 650 million in 2020. This has in turn opened up opportunities for more manufacturers to enter the market from different geographies. There were 5 in 2001 and there were 19 in 2022. And more than half of these new manufacturers are based in Africa, Asia, and Latin America. This has led to highly competitive prices and is eventually enabling countries to co-finance and self-finance their vaccine programs as the prices become more affordable. This cycle is critical for sustainability, which is at the center of Gavi's model. Therefore, developing strong relationship with countries as we go through this transition and a co-financing model is key. I will describe that a bit more briefly. So Gavi provides support to countries through three key financing levers. This is vaccine support, so procuring vaccines for countries, but also provides support in terms of cash for strengthening the health system, as well as providing technical assistance. This is mainly through in-country partners that support the activities of the immunization program. And this is the co-financing model, and it is, I guess, important to highlight that this model is recognized as particularly successful within the international development sector. It aims to bring countries on a trajectory towards financial sustainability and to empower them to take ownership of their vaccination programs. And this co-financing and transition model starts from the very beginning. Countries share the costs of the vaccine programs by directly procuring a portion of the vaccines and safe injection devices from a supplier or procurement agency to fulfill their co-financing requirements. As countries' gross national income per capita increases, so does the level of their co-financing as they transition across different transition stages. Countries are grouped under different categories according to their level of GNI per capita as a proxy of their ability to pay. And the idea is that as they transition through these phases, there comes a point where they are able to finance their immunization programs completely. We have, however, a middle-income country approach, which provides some catalytic funding for countries who have already transitioned or who have not received who have already transitioned from Gavi's support to ensure that coverage is maintained and that there is no backsliding. As I mentioned before, countries may also invest in their health system using Gavi support, particularly in areas such as service delivery, demand and community engagement, supply chain, health information systems, governance and policy, as well as human resources for health. We have seen a significant increase in the number of outbreaks from vaccine preventable diseases since the year 2020, with measles and cholera being the key drivers. The number of countries with large or disruptive outbreaks has more than doubled over the last 2 years, and the situation is also complicated by some countries facing outbreaks of diseases that they hadn't detected in years, and therefore facing challenges with timely detection and response. For example, cholera in Syria, Haiti in Malawi, and yellow fever in Kenya. This is compounded with some countries facing concurrent outbreaks aggravated by natural disasters. For example, Malawi and Mozambique suffered wild polio and cholera outbreaks with consecutive hurricanes. There's also a surge in outbreaks of vaccine-preventable diseases without established outbreak response mechanisms. For example, diphtheria outbreaks in several African countries, including Nigeria, Niger, and Guinea, which have also compounded the situation. So how does Gavi decide which vaccines should be added to its portfolio? And this is done through a process we call the vaccine investment strategy, which is done in advance of the development of a new strategy. So we have just finalized a vaccine investment strategy in June 2024 in advance of the next Gavi strategy 6.0 from 2026 to 2030. And the vaccine investment strategy is an evidence-based approach to identify immunization investments for future strategic cycles while sending valuable advance signals to vaccine developers and suppliers. We do it every 5 years, and it is based on a transparent methodology, analytic review of evidence, and health impact modeling. It is based on extensive consultations and includes independent expert advice. It aims to support strategic decision-making, so we don't make decisions on a first-come, first-served basis. It also allows predictability for long-term planning by industry, government, and donors. It will inform Gavi's strategy and its resource mobilization efforts, and it leads to different types of investment decisions. So vaccine programs, global stockpiles, or learning agendas, which are implementation, very small level of funding for implementation research questions that allow us to answer questions we need to launch successful vaccine programs. It is also important to highlight that in response to a public health threat, or a research and development milestone for a priority pathogen, Gavi can also evaluate vaccines against diseases of epidemic or pandemic potential in real time, so outside of this 5-year cycle, to be able to respond in a timely manner. So closing the immunization gap, there's a long road ahead, and this provides an example of the work that is still needed. So of 130 million children that were born in 2022, 20.5 million of those children are under-immunized. 71% of these are in Gavi-supported countries, and 1 in 5 children in these countries do not receive the full course of vaccines. In 2022, 10.2 million children were classified as 0 dose in Gavi-supported countries. These are children who did not receive a single dose of basic vaccines. And it's important to highlight that Nigeria and Ethiopia account for 33% of the 0 dose children in Gavi-supported countries. So Gavi's objectives till the end of 2025 are ambitious and are aiming to leave no one behind. Through the reduction of 25% in 0 dose children, aiming to reach an additional 300 million children through routine immunization, and averting 7 to 8 million future deaths, and reducing child mortality by 10%. And in the next few slides, I will give you a brief update on where we stand on what Gavi calls its must-wins, or priorities that it sets over the course of annual priorities to reach certain targets. So the first one is reaching 0 dose children, restoring a routine immunization and catch-up. And so Gavi has established a strong foundation for 0 dose programming with key strategic shifts, guidance, and tools established in the early years of the 5.0 strategy. The pandemic delayed the operationalization of these shifts, but we have witnessed a real acceleration of new programming in 2023, with 30 applications have now been submitted, and most of these investments are focused on reducing 0 dose children. We really need to focus on making sure the implementation of this new programming takes place, given that we did see a 5% increase in the number of zero-dose children in 2023. Therefore, the focus for us this year is on ensuring the quality of grant applications and focusing on strengthening the quality of implementation support in monitoring by actively leveraging existing initiatives. We also have the big catch-up, which is aiming to restore immunization coverage, catch up missed children, and strengthen health systems to reach zero-dose children. And in the next slide, I have an update on that, where we have 35 countries that have received, have approved support for this big catch-up funds. 50 million doses of vaccines have been shipped by September, and 11 countries have started their implementation. $290 million of the funding envelope have already been committed. And although there is a supply constraint for pentavalent vaccine that has been emerged, we are monitoring this to ensure to manage programmatic and financial risks associated with this potential delay. There's also rapid implementation. Rapid implementation is essential to reach the missed children, but success will depend on addressing outstanding risks such as the variability of in-country plans, operational funding gaps, and competing priorities at national level. I also wanted to highlight the progress on the HPV vaccination program. So we are on target to meet the target of reaching 86 million girls with HPV vaccine, with over 27.3 girls fully immunized since 2014, and more than 600,000 cervical cancer deaths averted. 14 million girls were reached in 2023 alone, more than in the past 10 years of the HPV program. New HPV vaccine launches are progressing, with 16 routine launches completed and 14 multi-age cohort campaigns. Some delays are being seen due to the supply constraint situation, with some campaigns shifting from 2024 to 2025. The current HPVC coverage in Gavi countries is at 16%, with the goal to reach 21% by 2025. It is important to highlight that the single-dose adoption is advancing, with 41 Gavi-supported countries having approved it and 21 already implementing it. Single-dose adoption will enable the available supply to reach more girls. And I also wanted to highlight the significant progress we have seen in malaria vaccine introductions, with many countries now moving into the implementation phase. 30 countries have formally expressed interest to introduce the vaccine, and 23 countries have submitted applications and been recommended for support. 12 countries, including the 3 pilot countries, have introduced malaria vaccines through their routine immunization programs and are now implementing at subnational level. Both malaria vaccines, RTSS and R21, are now being implemented in Gavi countries, and 7 countries have received approval to scale up the provision of these vaccines beyond their initial introduction areas. And now I will move on to briefly discuss Gavi's new strategy, 6.0, and outline what that means for our future agenda. So the Gavi 6.0 strategy will mark our programming from 2026 to 2030. And it was approved by the Gavi board in June 2024. And its development included taking into account key trends and externalities, such as the promise of new vaccines, growing inequities and renewed focus on universal health coverage and primary health care, deteriorating macroeconomic outlook, a spotlight on pandemic prevention, preparedness, and response, the climate emergency, innovation and immunization, fragility as the new normal in lower middle-income countries, and country ownership, regionalization, and global collaboration. This provides a very simplified snapshot of what that strategy is. So in terms of the vision of leaving no one behind and the mission to save lives and protect people's health by increasing equitable and sustainable use of vaccines, these remained unchanged. However, it is important to note that this is Gavi's most ambitious strategy yet, seeking to protect more people against more diseases faster than ever before. While Gavi vaccinated 1 billion children between 2000 and 2020, it is aiming to reach the next billion children in half the time. The principles that guide the strategy have not changed, but there have been some important additions that I will highlight in a following slide, as those will be guiding our programming for the next 5 years. In terms of the goals, we have introduced and scale up of vaccines, strengthening health systems to increase equity in immunization, improving programmatic and financial sustainability of immunization programs, and ensuring healthy markets for vaccines and related products. And I will go through give you some examples of the strategic priorities within these goals. So for strategic goal number 1, which aims to provide access to a wider portfolio of vaccines, we will be supporting countries to prioritize vaccines for their context, especially with a growing portfolio, country capacity constraints, and fiscally challenging environment. We will target and pay switches to Hexa and MMCV, and there will be no new COVID-19 program after 2025. We aim to deliver on the promise of new vaccines, including providing access to malaria and the VIS 2024 vaccines, which include the new TB vaccine and dengue vaccine. We will continue to advance the infant vaccine agenda and will expand vaccine stockpiles, support diagnostic procurement to accelerate detection, and ensure timely access to surge funding when outbreaks take place through the First Response Fund. In terms of strategic goal 2, which is focused on accelerating the equity agenda, we will accelerate the access to vaccines for 0-dose children, aiming to reduce their number by 50%. We are taking a priority to control measles and successfully delivering new vaccines like malaria. There will be targeted support to help routinely deliver vaccines to new age groups, particularly HPV, as I mentioned before. In terms of the strategic goal 3, we aim to enhance Gavi's eligibility, co-financing, and transition model. To ensure successful transition remains a cornerstone of Gavi model. So making sure that Gavi countries are still able to transition out of Gavi support. We aim to increase the focus on programmatic sustainability through greater differentiation of the health system investments and decoupling vaccines from programmatic transition, and address inequalities to access to vaccines in middle-income countries by mainstreaming the current middle-income countries' approach to a new post-transition catalytic phase in a subset of former and never Gavi-eligible countries. In terms of the last strategic goal on healthy markets, we hope to continue shaping the vaccine markets, including for self-financing countries post-transition from Gavi support, and working with partners to ensure access to delivery innovations that can help increase equity and efficiency. We will address supply security challenges by supporting a diversified regional supply base via the African Vaccine Manufacturing Accelerator, and continue to coordinate with alliance partners to improve market conditions for vaccines against outbreak and epidemic and pandemic-prone diseases. And this is my final slide. So I just wanted to highlight some of the changes in the principles that will be guiding our programming for the next strategic period. So we aim to bolster country leadership to sustainably finance and deliver immunization. So country-led was always part of our principles, but we have added sustainable to that. We aim to be country-owned and inclusive, so engaging communities and civil society organizations in planning, implementation, and oversight of immunization. We will revamp the alliance model to cater for fragile conflict and humanitarian settings. We aim to build a stronger global health security, including through outbreak pandemic response mechanisms and regionally diversified vaccine production. We want to ensure that Gavi's programs integrate climate change adaptation and mitigation. And we will continue to scale up innovation in immunization, as well as starting to develop the next chapter in building new partnerships, including with regional organizations such as the African Union and the African CDC, as well as other global health institutions in line with the Lusaka agenda. Actually, no, I had one more slide. So this, in order to prepare for all these shifts, we are busy working on an approach to operationalize what we need to have in place to be able to start working on the new strategy from 2026. We are developing the theory of change and the measurement framework for Gavi 6.0. We are finalizing key sub-strategies, including a health system strategy, a new approach to fragile conflict and humanitarian settings, as well as a market shaping strategy. We are updating Gavi's programmatic policies, and we are looking at how we evolve the alliance partnership approach, as well as the secretariat operating model. This is particularly important in terms of our grants management system, making it easier for countries and partners to navigate it and be able to provide support and funds in a much more efficient manner. So thank you very much for your kind attention, and I'm happy to answer any questions. Thank you.
Thank you, Michelle, for a very informative, interesting presentation. We are going to take questions. So the first question, to be fair, is going to come from the online people. Search, please, so you can.
So we have the first question from Abdul. He says he has two questions regarding innovation and funding and resource allocation. So he says, firstly, with the big catch-up campaign underway, are there new funding models Gavi is exploring to tackle logistical challenges such as cold chain management, data tracking, or digital micro-planning in under-resourced areas? And secondly, has Gavi considered adopting outcome-based funding models or incentive structures to drive improvements in both vaccine coverage and efficacy?
So the first question, yes, there are I'm not completely familiar with the guidelines on the big catch-up, but within Gavi's regular funding, there are opportunities to support both health information systems and a cold chain support. And in terms of the same question, the second question on developing incentives, yes, this is something that we are considering. A part of the 6.0 strategy is really looking at how, beyond the incentives within co-financing of vaccines, are there any incentives that we can provide to ensure programmatic sustainability of health systems? So making sure that as countries transition through the co-financing stages, some of the health system costs related to immunization are starting to be covered by domestic resources or other resources, so that by the time a country transitions out of Gavi support, these are sustainably financed within the country's system. Thanks.
Thank you. Are there questions from the floor? Okay, some on that side. I'm coming to you. who put their hand up first. Okay, you're up.
Thank you so much. My concern is on this quotation. 1 in every 5 children Gavi supported countries do not receive full course of basic vaccines. So my concern is this leading to another problem, given that you are not able to meet up with a full course of vaccination? 2, have you been able to identify what are some of those major challenges that are leading to this with all of the supports that you are giving to these countries? Thank you.
Just to clarify the question, do you mean full course of vaccines by the traditional vaccines that Gavi does not support, or in general,
I can restate
barriers
my
to
question.
coverage? Right?
I'm saying my concern is you have a slide that I talk about 1 in every 5 children in Gavi supported children do not receive the full course of basic vaccines. I'm saying, is that leading to another health problem? Could that lead to that? Because if you have to take a full course of a vaccine and then you are not able to meet up with that, could that lead to another problem? 2, what are some of those challenges that you have been able to identify that is leading to this particular situation?
Yes. So, I mean, part of what is being done by catch-up campaigns is ensuring that those children who have missed some of these vaccinations and are not fully immunized receive those vaccines in an orderly manner that is guided by recommendations from WHO or national recommendations in terms of how that catch-up must take place. So countries follow either global recommendations or their own national recommendations for that. And then, sorry, your second question, could you repeat it, please?
My second question has to do with, have you been able to identify some of those challenges that are leading to this particular situation?
I mean, it varies a lot by country context, right? And you have countries that a lot of these children are in communities that are very hard to reach, that are not necessarily always reached by government health services, which is one of the reasons why Gavi provides support to civil society organizations, because we see this as an important way of complementing support to governments to ensure that some of these communities are reached. And there are also settings that are either fragile or in conflict, and in humanitarian settings as well, where it's quite hard to reach these children. We also have, the health systems themselves are not necessarily strong in many places, and have difficulties reaching all these children. So I think it's not one particular barrier, but it's multiple barriers. And in some countries, they are, some are more important than others. So it's really, from the Gavi perspective, it's providing support and enough flexibility so that countries can address those barriers according to their context.
Thank you very much for the nice presentation. My question is about the transitioning from Gavi supported to co-financing. So first, what are the key criteria of transitioning from Gavi supported to that co-financing? And is it possible a country that has already transitioned to co-financing to return back again to the support, Gavi support? And okay, these are the two questions. Thank you.
Yes, thank you very much for that question. So the main criteria that is used for countries to transition through the co-financing model is GNI per capita. So once countries reach, right now I think it's currently $1,800 of GNI per capita, they move into a different phase of which is accelerated transition. And during that time, they have 8 years of Gavi support, with the idea that at the end of those 8 years, countries will be able to finance their vaccines on their own. We are currently reviewing that threshold. This is one of the things that we are doing in preparation for 6.0, because I think there is concern that many of the countries that are due to transition may not be ready to do so in the same way that some of the countries that have transitioned in the past. If the threshold of GNI per capita, it is being proposed to the board for their approval next month. If this is approved and that threshold changes, it will go up to $2,300. Then there are some countries who will return to either preparatory transition or accelerated transition, to preparatory transition stage. And we are currently working to support those countries in that transition. So yes, and the answer to your second question is that is possible, particularly if in this case, as we are making changes to the co-financing model. Thanks.
Thank you. So the game plan for the rest of the questions, there's somebody on that side who's already got a mic. You're going to go next, then somebody on this side, and then we're going to take 2 online questions and we'll call it for this presentation. Okay, so you're up for another 4 questions. Is that okay, Michelle?
Yeah, that's fine.
Great. Thank you very much for the presentation. My question relates to the HPV vaccination because I'm really interested in this. I understand that in Gavi 6.0, we are looking at the middle income countries. But then there are some countries that were never Gavi funded because they did not qualify. And looking at the accelerated plans for HPV, are there any funding models for these upper middle income countries to introduce HPV vaccines? Because they don't necessarily have a lot of 0-dose children, but they have deficiencies in terms of some of these vaccines like HPV. Thank you.
Thank you for that question. So yes, we do realize that there are gaps in many countries, including that are not necessarily considered for Gavi support. What we are doing in Gavi 6.0 is mainstreaming that middle income country approach. So it will now be part of the co-financing model. So it makes it I guess, more integrated into the model, and HPV is one of the vaccines that is supported through that catalytic phase. We currently don't have plans to extend the eligibility beyond those former and never eligible countries to upper middle income countries. And that is really because resources are finite, and we all have limited resources. So, yeah, that is.
Thank you so much for the opportunity. Thank you so much, Michelle, for such a wonderful presentation and very informative. I think from the beginning, we've really seen how the improvement has been, like how much we have achieved because of your financing us for the vaccines. So I kind of have 2 questions because I'm very much interested into knowing how is the project going with the malaria outroll in Nigeria that has recently taken place. So I just want to know how are the figures looking like as well. And part of your presentation, I think it was your second last slide where you were telling us about unpacking the key priorities. And on your slide, you did not really mention the 0-dose children as one of your priorities. However, one of your slides, they have the immunization agenda 2030 goal, where you wanted to reach the 0 dose to be like 50%, but then you didn't make it like a priority. So I want to ask, why is that? And the second follow-up question on that one, I just want to ask that, how can we really like help you guys to get out the data? I know that one of the things that we discussed in the house early today was the fact that we also don't have like the capacity in some of the provinces in South Africa where we're able to collect the data in as far as the 0 dose data is concerned to the children. So I hope my questions are clear. Thank you.
Yes, so yes, I do know that Nigeria is the most recent country to introduce. I don't have the actual numbers to hand right now, but I could potentially get some information from my colleagues that manage the Nigeria program and provide those for you as part of for you to have later on in the week, as I know you're going to be there for most of the week. In terms of a 0 dose, yes, I should clarify that reaching 0 dose children remains one of the priorities in Gavi 6.0. In my second to last slide, I guess I was talking a bit more about the principles that guide the strategic goals, which one of them, which includes reaching 0 dose children. And in terms of data, yes, I mean, Gavi uses data from most of the data that it uses to measure impact is through the WINIC coverage data from WHO and UNICEF. So that is gathered from governments. So providing data through those channels would be great. We also, through our in-country partners, also double check that data with administrative level data as well, to have a double check on that. So contributing to those systems would be very helpful to us.
Thanks, Michelle. Just to also say, there is going to be a malaria lecture on Thursday, so we'll hopefully get some information there as well.
Yes.
The 2 online questions, please.
So the first question is from Tambe, and he's asking, how does Gavi manage a situation where a country application is accepted? And he's giving an example of the measles vaccination campaigns, and because of field circumstances, the campaign could only happen a year later. So he's asking whether the country can go back and do the epidemiological analysis to reset the target population. And he's saying he's asking this question because where he worked, the country finds it difficult to request additional funds due to changes in, epidemiological outbreaks after a year, and that the measles vaccination could only be done based on data a year before, making the campaign potentially inefficient.
Yes, I understand there are some inefficiencies around both the application and the disbursement for many of these campaigns. I guess one of the things that we are trying to improve on, and I can speak more about the future rather than the present. In the future, we are aiming to have a consolidated cash grant, so countries will be able to plan in advance these measles follow-up campaigns and will receive funding for them in advance. So this, I think, will give countries more flexibility to be able to manage these changes in epidemiology as you described. So I think we acknowledge that there are some limitations in the current system, but we are working to address them in Gavi 6.0.
Sorry, if I may come in. Hi, Michelle. This is Amina.
Great, thank you.
This is a measles-specific question.
I saw you.
Complement your answer to it. We do usually have a lot of situations with countries applying for follow-up campaigns for measles or measles rubella program. And the application usually comes within a timeline of 12 to 15 months before the actual estimated launch date. So we do anticipate in some situations changes in denominators, changes in planning, where we find during the micro-planning stage differences compared to the initial plans that were submitted at the application stage. And even in terms of the timing of the launch, it can be delayed by a few months compared to the initial plans. There can be multiple changes from the application, which is basically a paper, to the actual implementation time. And usually there are some flexibilities because post application, there are multiple steps where the technical teams are in contact with the EPI teams on a regular basis ahead of the campaign launch. And during that time, there's a bit of guidance where those flexibilities are addressed in partnership also with WHO and UNICEF country offices. So there might be some flexibilities to work on, for example, additional funding through other work streams to support any of those gaps that might have not been anticipated at the application time. But sometimes the changes are too big. For example, there might be like a change in the population or a longer than 1 year delay from the initial expected time launch, where in those situations, there might be need for the country to resubmit again their application because the first application would have changed so much for the revised plans. Thank you.
Thanks. Last question.
So Adaura is asking, how can Gavi help Nigerians bring back GSK to Nigeria?
Yes, I'm not sure how Gavi can necessarily support that. We can, through our market shaping ability we work with many different manufacturers. So yes, not necessarily working with a specific one in a specific country. So maybe it's beyond what we can offer as something so specific.
Thank you so much, Michelle, for availing yourself. I keep going too near the speakers. Thank you very, very much. This has been a very good session. Before I introduce the next speaker, everybody please stand up, turn around once, and sit down. I won't make you touch your toes.
Thank you very much for having me.
Okay, everybody can be seated again. Thank you. It is my privilege to introduce Prof. Heather Zar for the next talk. You don't want to miss it. I see people walking out. Prof. Zar is a pediatric pulmonologist who chaired the Department of Peds and Child Health at UCT. She's an A-rated researcher. Her work is obviously on lung-related TB, pneumonia, asthma, HIV, AIDS-related lung disease. She's served as the president of the Pan-African Thoracic Society. She's also served on the NCD Task Force for Essential Drugs for Children. In 2018, Prof was awarded the L'Oreal UNESCO Women in Science Laureate for Africa and Arab states. And I could go on, but I won't because I'm going to let Heather speak. Thanks, Prof.
Thanks so much for such a generous introduction, and really thank you for the opportunity to be here again. It's really an amazing course and wonderful to reconnect with people and meet new people and learn so much just listening to the prior talks. So I'm really pleased to be able to speak to you today on respiratory syncytial virus vaccines and prevention of illness in infants. Where are we now? Because I hope to show you that we're in an incredibly exciting time with the potential to really impact in terms of reducing childhood pneumonia, reducing burden of disease, and improving and reducing mortality. My talk today is going to focus in 3 areas: the epidemiology of RSV disease in infants, and then I'll focus on the 2 new interventions maternal vaccination, and long-acting monoclonal antibodies. So many of you know that RSV is the major cause of severe respiratory disease and hospitalization in young children. You see here the global data, 33 million episodes annually, around 10% of those require hospitalization, and over 100,000 deaths. And if you look at the age group in which these are occurring, you'll see that almost half of all deaths, oh, sorry, I'm not very good with this pointer. Let me try. Is that showing now? But I've gone to the next slide, so I need to go back. Okay, there we go. Sorry, challenge. Almost half of these deaths are in children under 6 months of age. And in fact, RSV accounts for over 3.5% of all mortality in infants under 6 months of age. And of course, as we all know, 99% of these deaths occur in low middle income countries. And this is highly relevant to the new interventions, which offer protection to infants for the first 6 months of life. Now, this is a study, some of you may be familiar with it. It's a cross-sectional study of children hospitalized with severe pneumonia or very severe pneumonia in 7 countries in Africa or Asia, the PERCH study. And what's shown there is the proportion of cases due to RSV, and you see the circle shows the number, it gives you a sense of quantity. And I think it's very evident that RSV is the major pathogen causing severe or very severe disease in these hospitalized children. Just to say, most children in the study, in fact, had received pneumococcal conjugate vaccine. One of the motivations for doing this study was to see what the residual burden of pneumonia in children is when there's good coverage with pneumococcal conjugate vaccine and Haemophilus influenza type B vaccine. And you see there RSV jumping out hugely in terms of almost 1 in 3 cases, 31% being due to RSV. And if you look by WHO region, you will see, and for Africa, the first purple column there, again, very consistent. 34% of all hospital admissions for respiratory infection due to RSV. And you see that, in fact, it's even higher in other geographical areas. What about mortality? And again, the purple graph will jump out at you. In fact, the number of children dying from RSV is highest in Africa. Almost over half of RSV deaths occur in Africa. And so while RSV only accounts, not only, but accounts for around 1/3 of admissions, you see that it accounts for more than 50% of deaths. And this speaks to lack of access to care, lack of oxygen, lack of other supportive interventions in Africa for children. What I should preface, what I should say there is we know that there are almost 4 times as many deaths occurring out of hospital than are occurring in hospital in these areas. And so again, an intervention that can prevent severe RSV disease is likely to have the greatest impact in these areas where we're experiencing very high mortality due to RSV compounded by lack of access to care. So what has been the problem with development of a vaccine for RSV? And for a long time, it's been known that the target for an RSV vaccine should be the fusion or F protein on the viral surface. And this is the virus, this is the protein that fuses to epithelial cells, enabling the virus to invade these cells and cause disease. And the problem was that the F protein is very unstable and undergoes dramatic structural changes before it fuses and after it fuses. And this is shown here. You see the pre-F form and the post-F form. And you can see the pre-fusion form is very, very different. And the real breakthrough came in stabilizing the pre-F form. And you can see that this pre-F form has multiple sites, multiple neutralizing sites, many more and better sites than the post-F form. So once this pre-F protein could be stabilized, then work could continue in terms of developing a vaccine or long-acting monoclonal against the pre-F form of RSV. And this has been a real breakthrough. So the best way to protect young infants, as I don't need to tell this audience, in the first few months of life is by passive immunization, because of the inability to mount active response in very young infants. And so 2 ways to do this as far as RSV goes: maternal vaccination given during pregnancy, or long-acting monoclonal antibody given to infants shortly after birth. And I'm going to turn to each of these specific interventions, show you the data in efficacy and safety, and also discuss where they may fit in immunization programs going forward. So RSV maternal immunization, and as all of you know, maternal immunization is not new. There's a whole session on maternal immunization in this program, and it's been widely used for tetanus toxoid, tetanus diphtheria vaccines. It's contributed hugely to the reduction in tetanus, neonatal tetanus. And in some countries like South Africa, we've also just implemented pertussis vaccine, also a very effective strategy for reducing pertussis in young infants. And you know that the mechanism whereby vaccination works is by increasing maternal antibodies to the particular virus or bacteria, and transplacental transfer. So in the case of RSV, all mothers have seen RSV in the past, but levels of antibody are generally quite low. And there is some transplacental transfer, but it's low, insufficient amount to protect the baby against severe RSV disease, and also only because the babies start with low levels, the duration of protection is quite short. Whereas with the maternal RSV vaccination, you boost those levels up high, there's good transplacental transfer, and the baby is protected. And let me show you some of that efficacy data. So the pivotal trial is the phase 3 Matisse trial. This is of the pre-F form of the RSV maternal vaccine produced by Pfizer. And in this trial, around just over 7,400 pregnant women, this is important, enrolled between 24 and 36 weeks of gestational age. That was the time at which they got the vaccine, across 18 countries. Around a third were low-middle income countries. And there were around 7,300 infants born to these moms. And the randomization was 1-to-1 to pre-F vaccine compared to placebo. And here are the efficacy results. The primary outcome was severe medically attended RSV at 90 days. And you see the efficacy there of 83% or 82% through 90 days. And you see sustained efficacy of 70% through 180 days for severe medically attended RSV. And if you look at less severe disease, so medically attended RSV disease, the efficacy was around 58% at 90 days and around 50% through 6 months, through 180 days. Importantly, the efficacy was seen from day 1 of birth, which makes sense because the antibodies are present, and it was incremental through 6 months. With sustained efficacy through that 6-month period. Now, what about adverse events? There was no difference in adverse events between placebo and vaccine recipients amongst mothers, and generally adverse events were well balanced between babies born to mothers who were vaccinated compared to babies whose mothers received placebo. However, there was a numerical imbalance in prematurity amongst with babies who were born to mothers vaccinated, 5.7% being premature compared to 4.7% amongst mothers who received placebo. And if you look at low birth weight as another proxy, you see there was still an imbalance with around 5.1% of babies born low birth weight amongst mothers who were vaccinated versus 4.3% amongst those who received placebo. You can see that this difference is slightly less than the preterm imbalance. I just want to highlight that gestational age here was estimated using antenatal ultrasound in the first or second trimester. And in most low middle income countries, this was done in the second trimester because, as we know, pregnant women tend to present later, as opposed to high income countries where most women had antenatal ultrasound in the first trimester. And the reason that this is important is because second trimester ultrasound can underestimate gestational age by at least 2 weeks. So in other words, the estimate of gestational age in these groups may have underestimated gestational age, and these babies may, in fact, may have been older. Now, why is this important? This is important because most preterm births were late preterm births, and this imbalance in preterm births occurred largely in two countries, South Africa predominantly and Argentina, and I'll show you that data. As a result of this data has been very carefully interrogated, and multiple regulators, modeling studies, and most recently WHO SAGE confirmed that the benefits of vaccination outweigh the risks. But they also emphasize the importance of post-introduction monitoring for surveillance. So let's look at the preterm deaths a little, the preterm births a little more closely. Here you can see babies born preterm compared to those who are born term. You will see that around 60% or more of the preterm births occurred after 30 days of administration of the vaccine. So that's the first important point. There was no temporal association between giving the vaccine and between preterm births. The second important point, I think, as I mentioned, was that almost all preterm births were late preterm births. And here you see preterm births by gestational age. And you see there's absolutely no difference until around 33 weeks, where there's an increase or there's a difference with a higher number of preterm births in infants born to mothers vaccinated compared to infants whose mothers received placebo. And then you see at around 35 weeks, the curves sort of come together again. So these are all late, predominantly late preterm births. And the third point is here I'm showing you the imbalance in preterm births by the 8 countries in which there were 5 or more preterm births. And you'll see that this imbalance is largely driven by South Africa, with differences in 39 to 19, and somewhat by Argentina, but not significant in Argentina. And you see that for some high-income countries like Japan, in fact, the risk is completely opposite. There is no risk. If anything, infants born to mothers who receive vaccine are protected from prematurity. Now, one observation about the preterm births in South Africa is that these preterm births occurred largely coincident with the Delta wave of COVID and somewhat with the Omicron wave. We know that SARS-CoV-2 itself is a cause of prematurity in infants. So there was a fairly strong temporal relationship between the Omicron wave in South Africa and this imbalance as shown here. So there is no clear biological explanation for this imbalance, but it does seem somewhat related to SARS-CoV-2. The last point I want to make about this preterm imbalance is that this imbalance did not translate into increased deaths. And if you look here, there was one preterm death amongst infants born preterm in the vaccinated maternal group compared to 2 in the placebo group. So if anything, a reduction in deaths amongst those born preterm in infants who were born to mothers who had received vaccination. Obviously, these numbers are very small. They're not significant. But I think it's reassuring that no increase in death was seen, if anything, a reduction in death. And so, as some of you may know, WHO just made a recommendation at the end of September SAGE made a recommendation that all countries introduce passive immunization for RSV prevention in young infants. And this recommendation extends to maternal immunization as well as to the monoclonal antibody. The specific recommendation around maternal vaccine is that if countries decide to go the maternal vaccine route, a single dose should be given in the 3rd trimester, which is defined as 28 weeks of gestational age and up, although in the local context, it could be different. So it could be as low as 27 weeks, for example. There is no upper limit for gestational age of vaccination. However, women should not be vaccinated during active pregnancy, and reassuringly, it can be given with other vaccines in pregnancy. This is a summary of the product that is available, the Pfizer Pre-F vaccine, globally just recommended in September by WHO. It's been recommended by PAHO. There have been regulatory approvals. They began in the United States in 2023 and the European Union as well. And other high and upper income countries have followed. Vaccination during a defined gestational age window for protection of the infant. As I said, WHO has recommended 28 weeks and up, a 3rd trimester. And the question of whether to give seasonal versus year-round immunization depends on programs, depends on RSV circulation, and depends on the context, right? So in tropical and subtropical countries where there may not be seasonal circulation of RSV, a year-round approach is going to be needed. But where RSV seasonality is clear, and I think we have returned to post-COVID seasonal patterns again, and where the programmatic capacity exists, a seasonal approach may be appropriate, but vaccination would need to start several months before the RSV vaccination season. I personally think a seasonal approach for maternal vaccination is very challenging for programs. And I think that a programmatic approach using a year-round approach for maternal vaccination is probably much more feasible for most contexts. It's given as a single dose intramuscularly. It uses standard cold chain. It currently exists as a single dose. There is a work underway to develop a multi-vial funded by the Gates Foundation, and at the moment, immunobridging work is being done to establish the similarity of that to the single dose vial. And so here you can see the global regulatory and policy approvals of the vaccine. You will see in blue are where it's actually been rolled out. Argentina has had an incredible program. They've vaccinated 134,000 women, almost 60% coverage of their pregnant women cohort in a seasonal approach. So they started vaccination in April and have just completed through August to try and reach all pregnant women during that time. Very well accepted, no safety signal that we know of to date, and we wait to see the data. Importantly, they gave it at 32 to 36 weeks of gestational age. Luxembourg, France have also recently started. The UK started their national program in August 2024. And then the only upper middle income countries that have approved and implemented are Brazil, Dominican Republic, and Argentina, shown in yellow there. And you'll see that different countries have made different recommendations for the gestational age of vaccination. I think now the WHO SAGE has just made the recommendation for 3rd trimester. It's likely that other countries will follow suit, and that may become a more standardized recommendation. Okay, let's turn now to the long-acting monoclonal antibodies. And as many of you know, these are antibodies that are manufactured and directly kill a virus or other pathogen. They obviously protect immediately. They don't require the infant to produce their own antibodies. And some of you may be familiar with palivizumab. This is a short-acting monoclonal antibody that has been used for a long time against RSV. In fact, it was licensed since 1998. But the problem with palivizumab, requires monthly injections, so up to 5 injections through the RSV season. Secondly, it is incredibly expensive. And so as a result, use has really been restricted to very high-risk infants, such as those with congenital heart disease, chronic lung disease, and even in our context in low middle-income countries, it hasn't been feasible. Even in high-income countries, it's had that very restricted use. Now, I do need just to remind you that, in fact, the biggest burden of RSV hospitalization, disease, mortality is not in high-risk infants. It's in full-term healthy infants. Because these are the biggest numbers. And so we actually need to protect everyone, all infants. We need an intervention that doesn't only target high-risk infants. And now we have 2, I think, really effective long-acting monoclonal antibodies. I'm going to show you the data. The first on nirsevimab, which has been licensed since 2023 and which WHO SAGE has just recommended. And the second on clesrovimab, which is in late phase evaluation and has very good phase 2b/3 results. So let me show you these results. So first of all, nirsevimab, and what I'm going to show you are the results from the pivotal trials. The first is a phase 2b study. It enrolled preterm infants, just almost 1,500 infants, aged between 29 to 35 weeks of age, 23 countries, 163 sites, are quite diverse. The second is called Melody, which was a phase 3 study of term and late preterm infants, so over 35 weeks of gestational age, just over 3,000 participants, and again, 31 countries, quite diverse. To just a point of clarity that in the phase 2b study, the original study, 2 doses were used, 50 milligrams. Only a 50 milligram dose was used, which was given to all infants. But what was discovered in the study that if an infant was over 5 kilograms, that dose was inadequate. You actually needed to give a 100 milligram dose. So the data I'm going to show you is the combined efficacy data from these 2 studies, but it only includes infants who got the correct dose. So 50 milligrams if they were under 5 kilograms, 100 milligrams if they were over 5 kilograms. And it's given as a single dose. Once-off dose protects the child for the duration of the season. There are also 2 other studies of high-risk infants, immunocompromised, or children with underlying congenital heart disease, chronic lung disease. So let me show you, this is the combined efficacy data for protection against RSV disease through 5 months of age. And you will see that for all these outcomes, medically attended RSV, lower respiratory tract infection, hospitalized disease, severe hospitalized disease, the efficacy is very high, 79, 80% protection, incredible efficacy. In addition, important impact in reducing all-cause pneumonia or all-cause LRTI. So almost a 44% reduction in hospitalizations for all-cause lower respiratory tract infection. 35% reduction in all-cause medically attended lower respiratory tract infection. And this, of course, translates into a substantial reduction in antibiotic prescribing. And we know that RSV and that pneumonia itself is often not a single pathogen. It's interaction of different pathogens, and that also there is an association between early life RSV and subsequent recurrent pneumonia. So this impact on all-cause LRTI has really huge public health benefit and important. And these results have been confirmed in a pragmatic clinical trial called Harmony of over 8,000 infants. This was done in the UK, Germany, and France. In this trial, healthy infants randomized to receive nirsevimab or usual care, which did not include nirsevimab, and you see similar reductions, 83% in RSV hospitalization and almost 60% for all-cause hospitalization. So, overall safety profile, very, very good. And we now have a lot of effectiveness data that is accumulating, showing the incredible effectiveness of this product. The red is reduction in RSV-related hospitalization. The purple is reduction in ICU admission for RSV. And you see across these high-income countries, unbelievable reduction in terms of hospitalization and ICU resources. In fact, if you speak to the clinicians in these areas, they tell you their wards were empty during the RSV season. This has changed the face of admissions for childhood pneumonia in these areas. I want to show you one example from Galicia, Spain, where they did a universal coverage a campaign with nirsevimab. They immunized all infants born during the RSV season. They immunized infants up to 6 months of age during the RSV season. So if an infant had been born prior to the RSV season but was younger than 6 months during the RSV season, that infant was included. And they immunized high-risk children who were entering their second RSV season. And they achieved incredible coverage, like 90% coverage. And look at the effectiveness data. 87% reduction in severe RSV, lower respiratory tract infection requiring oxygen, 82% reduction in hospitalization, almost 70% reduction in all-cause hospitalization for lower respiratory tract infection, and similar results for all-cause hospitalization. Extraordinary results. And the last slide I want to show on this comes from Chile. And Chile also introduced universal immunization with this product recently in a similar way to Galicia. And this data was presented just 2 weeks ago at ID Week. And you can see these are the curves for RSV hospitalizations amongst eligible children. So in the same way, these would be infants born during the RSV season or under 6 months in the RSV season or high-risk infants. And you see the curves for the preceding years, and you see what happened in 2024. Disappeared. But if you look at non-eligible children, so children who are older than 2 years, who didn't receive the product, you see that the curve is very, very similar to that of previous of 2022, actually. So clearly, extraordinary impact in terms of hospitalizations, not only for RSV, but for all-cause hospitalization. Now, as I said, there's another long-acting monoclonal antibody on the horizon, clesrovimab. This is from Merck. This is given also as a single dose, different to nirsevimab. It doesn't have 2 dosages, 50 and 100. It's got a single dosage of 105 milligrams, given in the same way. And this is the results from the pivotal phase 2b/3 study. These results were just presented last week at the World Vaccine Congress. And here you see the different outcomes for RSV acute respiratory infection. So that's upper respiratory infection, medically attended RSV requiring 1 or 2 indicators of severity, and hospitalization. And what you see here is that efficacy ranges from 52% for the mildest outcome all the way to almost 92% for the most severe outcome through 5 months. And if you look through 6 months of administration of the product, that efficacy is maintained. So again, really excellent results showing that a single dose protected against mild, moderate, and severe RSV, sustained through 6 months. Again, this trial was almost 3,600 infants done in many countries, and showing sustained protection. And you know, a product like this, if it could get out to the children who really need it, would change the face of RSV disease and of pneumonia in infants generally. So where are we in terms of these products, and what is the best way to deliver these? I don't have to tell an audience like this about BCG, because if you give a long-acting monoclonal, a birth dose is probably a good programmatic place to start. There are high rates of BCG coverage in many of the areas that we work in. And so what did SAGE recommend in terms of long-acting monoclonal antibodies? a single birth dose to all infants born in the RSV season, where a year-round approach is considered. If that cannot be given at birth, should be given at the earliest opportunity in one of the first EPI program visits. Or can be given prior to the RSV season if it is not, if a seasonal approach is preferred. SAGE noted with concern the limited availability and high cost of the current monoclonal antibody, which has potential to limit global access and equity. So to summarize, the available long-acting monoclonal nirsevimab, been globally recommended by WHO. It's recommended by PAHO. It was first approved in the European Union in 2022, followed by the United States 2023. Several high and upper middle income countries have followed suit. If RSV circulation is year-round, it should be given year-round. But where seasonality is clear, a seasonal approach may be preferable because it will be more cost efficient. And it may be should be given as a birth dose during the RSV season or prior to the RSV season in young infants or susceptible children under 2 years of age. Just to say, if for children under 2 years of age going into their second season, a dose of a double dose was given in the Galicia study, so 200 milligrams. It's given as a single dose, intramuscular injection, standard cold chain, and it comes as a standard liquid filled pre-syringe. What about the additional considerations in terms of which product to choose? And this is what SAGE has recommended. Countries obviously need to consider cost, financing, supply, anticipated coverage, and programmatic feasibility. Both products can be co-administered with other vaccines. It's important to have post-marketing surveillance, and the issue of seasonal versus year-round administration, I think we've discussed. In countries with clear year-round circulation, a year-round approach, of course, is obvious, but in those with seasonal circulation, particularly for the monoclonal antibody, a seasonal approach may be more cost-effective. So what's happened? Where are these products available and used? This is a little bit out of date, but up to August 2024. In blue are where both products are available, in green where nirsevimab is available, and in red where the maternal vaccine is available. And it's quite obvious that these products are absent in our settings. And this is a huge problem. Because we've spoken about where the burden of disease is, we've spoken about where the burden of mortality is. We haven't even spoken about the impact of early life RSV on long-term health, which is a whole other talk, and where we increasingly understand that early life RSV disease sets children on a trajectory for impaired health and for development of chronic disease. And we know that the cost of RSV illness is very high, not only for health systems, but for households and for families. And here, for example, in Malawi, one RSV admission costs around a third of total household monthly income for the lowest income households. There are cost efficacy analyses, and these products, while they are now fairly expensive, the cost efficacy analyses actually show that there may be cost saving in some areas and even cost effective. And so, for example, for South Africa, it was estimated that the monoclonal antibody may be cost effective even at a cost of $120 a dose, because the cost of RSV hospitalization is such a lot. And that estimate of $120 is an underestimate, because in that model, the protective efficacy was only estimated at 3 months. And I've shown you the data now. We now know that the protective efficacy is for 6 months. We also hope that now with another long-acting monoclonal, prices will go down, and with tiered pricing and other options, that we may in fact see affordable prices. I'm not going to speak about Gavi. We've just had a whole talk on that. Of course, Gavi's support for these products is going to be crucial. You saw in the previous talk that Gavi has in its armamentarium RSV in the plan, the 5-year plan for 2021 to 2025, and it's hoped that renewed support for RSV will occur if these 5 criteria are met. We do have a SAGE recommendation currently, and WHO pre-qualification for the multi-dose vial for the RSV vaccine and for nirsevimab is currently underway. So this is an estimated timeline of immunization product available for Gavi eligible countries. On the top for maternal vaccine, on the bottom for monoclonal antibodies. This is the single dose vial for, and the dotted line, sorry, is where we are at, the green dotted line. This is for the single dose vial for maternal vaccine, the multi-dose vial. And you can see that the estimates are for 2026, 2027 onwards. I think this is an urgent priority. I know there are many other competing priorities, but given the potential impact of these products and the potential to really change the face of child health, reduce childhood pneumonia, I think we had a very unique period where for the first time we have highly effective new tools that can prevent RSV disease in early life, either maternal vaccine or long-acting monoclonal antibody, the potential to save millions of hospitalizations, thousands of deaths, reduce strain on health systems, open up beds for other needs, reduce financial strain on families, and really improve child and long-term health. And that is my last slide. Thank you very much.
Thank you, Prof. That is amazing. I'm going to start with questions from the floor.
Whoa, that's always a
Okay.
good sign.
Let's start with Prof. Gold.
Thanks for a fantastic talk. Can you talk a bit about if the either or, in other words, maternal vaccination or monoclonal, you know, what has been done in terms of, you know, choosing one approach to the other, or even looking at the, you know, cost effectiveness of either approach?
Thank you. I mean, this is a very important question that each country is going to have to decide for themselves, right? I think there are multiple considerations here. First of all, programmatic considerations. How strong is the maternal immunization program, or can introduction actually be used to strengthen the maternal program? Bearing in mind that the recommendation is from 27 or 28 weeks onwards. So programmatic feasibility is one, versus the monoclonal antibody, giving it at birth. As we said, BCG is, you know, usual in our context. The 6-week EPI vaccination is also usual and high coverage in our context. So those programs are well developed. One issue about two issues about maternal vaccination is, number one, who actually gives the vaccine. So for example, in Argentina, they chose not to give it in antenatal clinics. They chose to give it actually in immunization clinics. So they send pregnant women to primary healthcare clinics to do maternal immunization. So that's a big shift, right? The second is acceptability to mothers. We know we saw a lot of vaccine hesitancy, particularly in pregnant women. We saw that in COVID. So these are issues that would need to be addressed. The second big issue is, of course, cost. Big driver of what is implemented is going to be cost. And actually, you would think the maternal vaccination is going to be a lot cheaper. But if you look at the price in high-income countries, you'll be surprised at how high the cost of maternal vaccination actually is. So now, you know, I think we need to, manufacturers hopefully will come to the party. Pfizer is developing a multi-dose vial, which with funding from the Gates Foundation, which will hopefully bring the maternal vaccination price down. with a competitor long-acting monoclonal clesrovimab. Hopefully the price of the monoclonal would come down. Chile negotiated a price with the manufacturer of nirsevimab for a more reasonable price. So I think price is a bit of a moving target. There's also a lot of talk about tiered pricing, what is a Gavi acceptable price, and then also a voluntary licensing to other manufacturers, which of course would be a really innovative and good way to do that. And that's the way that HIV drugs, have. So, but I think pricing is going to be a very, very key issue.
Hello. Hi. Thank you so much. It was a very wonderful presentation. I just wanted to find out, so going back to the preterm labor issue that you had in the beginning. So when we're looking at maternal vaccination, should we be considering some of the maternal confounders that are like specific to like certain women in certain regions, and also maybe some diseases that they may have in terms of the effect of those conditions on the vaccines, and seeing some of the temporal causality effects of like preterm labor that we saw in the example that you gave?
Thank you. Another very important question. So just to clarify, there was no temporal relationship between giving the vaccine and preterm birth, right? And most preterm births were after 30 days of vaccination. However, the trial included relatively healthy women, single pregnancies, HIV negative women, so relatively healthy women who, would have a lower risk of preterm delivery anyway. And that's borne out by the rates of preterm delivery in all the countries were much lower than the average rates of preterm deliveries in those countries. What's happened since then is there's been a trial of HIV, of women living with HIV, pregnant women living with HIV, which is just concluding. That's more a safety and immunogenicity trial, and the results of that should be available quite soon. It's just concluded. In addition, there is what's called an impact trial, which is going to start early next year, which is really a phase 4 trial in South Africa, 6 sites, and in Africa, another 3 sites, I think. And that is really going to enroll around 9,000 all-comers, pregnant women with all risk factors, and will report on safety and follow up infants to 6 months. So we will have that data. Having said that, however, remember that in Argentina, 135,000 women enrolled on the vaccine, all comers. So this does include women with preeclampsia, high blood pressure, women who've had previous preterm births, et cetera, some of the risk factors that we would be concerned about preterm births. And I think, that data is going to be quite reassuring.
Thanks, Heather. That was a brilliant talk. So in the South African scenario, would anybody be concerned about having more vaccines in the maternal side versus more vaccines in the versus monoclonals in the pediatric side? Is anybody asking if they overloaded on each side or not?
Yeah, look, I think we're not at the stage of implementation yet in South Africa, but the program would have to decide on one of the 2 options. Many countries have chosen to authorize both, and I think that's the right approach, because the more options you have, the greater the protection. Secondly, even amongst mothers who are immunized, there's still a group of infants who might need the monoclonal. And what I didn't speak to was how long before you need immunization to provide adequate antibody levels in the infants. And the pharmacokinetic data shows about 2 weeks. So any mother who gives birth 2 weeks or less of immunization, their infant, would still benefit from a monoclonal. And obviously for high-risk infants, the monoclonal would be indicated. I think for programs, it's very confusing, though, to have both interventions. And so, the program is going to have to choose one or the other. Currently, both are at SAPRA for approval. And And currently, the maternal vaccine has been to NAGI and a recommendation has been made.
Okay, we're going to take an online question, please.
We have a question from Festus. So he's asking, what is the difference between GSK and Pfizer RSV vaccines, and why is the CDC limiting booster shots for aging clients?
Sorry, why is the CDC limiting booster shots for?
Yeah, for aging clients, for old.
Okay, so I think so some of you may know that there's a GSK pre-F vaccine that's actually licensed for use in elderly adults. The same Pfizer vaccine that I presented here is also licensed for use in elderly adults. And it in the elderly data suggests that booster doses do not boost the levels of antibodies as much as you would expect, right? The elderly data suggests that in fact protection from one of these immunizations is for about 2 seasons for RSV in the elderly population. And then if you get a booster dose, you don't get hugely boosted levels of antibodies. So I think that's what it's referring to. In terms of the GSK vaccine was also trialed in maternal pregnant women, and the trial was discontinued because of an imbalance in prematurity. Now, if you look at that data very, very carefully, once again, this is a very odd signal, right? It's not even a signal, imbalance. Firstly, the imbalance only occurred in upper middle income countries. Secondly, it only occurred during the time of COVID, coincident with the Omicron or the Delta waves. Thirdly, no relationship between timing of immunization and actual preterm births. But GSK discontinued that trial based on those results. What the CDC is currently recommending for subsequent pregnancies, and I think this is maybe what is being alluded to. So if a mother received vaccination, baby was born, and then falls pregnant again, the CDC is recommending a long-acting monoclonal in the second pregnancy given to the infant because of this issue of not knowing how long antibodies or how much antibodies will be boosted with the second immunization in mothers.
Okay. For the second question, Leah is asking, were there any reported SAE, I'm assuming serious adverse events, and SASAs related to the vaccine during the conduct of the trial? And what kind of adverse events presented more commonly during the study?
So in general, adverse events were balanced between the placebo and vaccination group. The adverse event of special interest, I've shown you prematurity and low birth weight. That was really the key one.
Thank you very much, Heather, for a very informative presentation. I was quite interested to see the data on the real world impact in some of the countries and vaccine effectiveness. And I think it would be nice for our region to do this kind of studies given the high disease burden. However, I don't know what you would envisage in terms of doing this in Africa, given that the RSV surveillance is very weak. Would we be using the like the hospitalizations? But for the VE, I wasn't quite sure how they did that and how this can be done in Africa. Thank you.
Thank you so much. I mean, that's also a very important point about the strength of RSV surveillance platforms. So I think if you capture hospitalizations, you're capturing the most severe form, at least hospitalizations in hospital. And you can see the highest VE is for those severe outcomes, hospitalization. So I think that's a good, I completely agree with you. I think this is an opportunity for Africa and for African countries to really lead in terms of some of these effectiveness studies, and we should be doing them. And they could also be used as an opportunity to strengthen surveillance. You know, diagnosis of RSV is fortunately pretty straightforward. It's a rapid PCR and a nasopharyngeal swab. These rapid diagnostic kits They've been rolled out since COVID. They're cheap, they're quick, they're effective, and they're reliable. So I think this could be used as an opportunity to actually strengthen surveillance as well. If you get RSV, it's almost always pathogenic. You know, it's not like pneumococcus. If you get it in the nose, you don't know, is it colonizing? Is it the actual pathogen? In RSV, we have a pathogen in a symptomatic child. So.
Okay. Thank you very much. My first is a comment. I noticed that most of the studies in the African continent, most of it was done for Africa, was done mostly in South Africa. That's one. Then second thing is I would like to ask, because we can see from what you presented to us that the probability of rolling it out in Africa is not anytime soon. And that so I'm thinking, what's the cost effectiveness? For the African country, I think part of the presentation said that we might need, of course, if Gavi or other organizations were able to subsidize for us to get this vaccine. So if we're not able to get, I'm just thinking, you know, for cost effectiveness, which one will be better? Your opinion, Ma. Whether we go for the maternal vaccine or for the infant vaccine, which one? Because we might not be able to afford to get both of them.
Yeah.
So which would be better?
Thank you. These are crucial questions. So you're right. And there is an omission. Gambia was also included in some of the trials. But you're absolutely right that there's an absence of African countries. The impact trial will include some other African countries. But it's a big omission and it's a problem that, you know, these high burden countries are not included. In terms of cost efficacy, I think I have to come back to, you know, this depends on the cost of the actual product and what it's going to be made available at. In general, people are of the opinion that the maternal vaccine is going to be of lower cost, particularly if a multi-dose vial is available. But as I've said, you know, cost is a moving target, and we saw with HIV and, for example, with triple therapy in HIV, how cost came down substantially with voluntarily licensing and with sort of out of the box different interventions. There are some very good analyses of cost efficacy. I alluded to the cost efficacy in South Africa that was done for Kenya as well. Just to bear in mind, you know, that the cost efficacy, if you don't hospitalize children and they die outside hospital, you know, cost efficacy becomes, you know, it's less striking. So, for example, the cost efficacy was higher in South Africa, you know, you could show that $120 a dose was cost effective in South Africa, whereas it was only at $20 or $40 a dose in Kenya, because the cost of hospitalization was so much lower. But I can refer you to, I should have put in a slide, I'm sorry, to some of the analyses that may help. And I think ongoing cost-effective analyses are going to be very important. So if there are effectiveness studies, you must include efficacy analyses and surveillance. Yes. Thank you very much.
Thank you so much, Prof. I'm going to have to cut the questions there. Thank you, Heather. Just before we all run out here for lunch, please, can somebody indicate, has anybody, there was a list going around for Prof. Gold's workshop at 5 o'clock? It's over here. Okay. And there's another one, 5 till 6 for the, oh, sorry. It says 6 till 7. What time is it? Prof. Gold can say. Time would you like to do it, Prof? So 5 o'clock, 5 to 6. Okay, so Adina, it's here somewhere. And then everybody, please come back 5 minutes before we're due to start again. I think that's at 5 to 2. Thanks. Oh, sorry. Salim also wants to say something.
Okay, I don't want to make the announcement. What is the announcement? Okay, so the first announcement is, can I go to the front, sorry? The first announcement is tomorrow, the amazing organizers, those two over there, plus Alana, have thought it would be nice to take you guys to the waterfront, experience Cape Town a bit. The transport on us. The shopping, hey, that's all you guys. So if anybody wants to sign up to go for a trip to the waterfront, there's going to be a list at the registration desk, right? And you have until end of today to sign up for it, I guess. There's also another list for your certificates. We want to make sure that your names are correct. So there's going to be a list with all your names next to that list on the registration table. When you get a chance throughout the day, sooner the better, just go and make sure your name is correct on that. Okay? And make sure you sign attendance register. Thank you.